and co-founder of Relief Technologies Private Limited. It is an AI company, mostly working with AI product and AI technologies. So, आज चाहिँ मेरो टकको टाइटल छ AI machine learning and data science trends. अहिलेसम्म भएको टेक्नोलोजी AI टेक्नोलोजी र फ्युचर अफ AI टेक्नोलोजी को बारेमा म चाहिँ आज कुरा गर्नेछु. सो यो अहिले नयाँ कन्सेप्ट चाहिँ AI लाई चाहिँ न्यू इलेक्ट्रिसिटी भन्ने कन्सेप्टले लिएको छ. As it is empowering the business and industry, so it is the new electricity. So time boundले गर्दाखेरि I have to finish it within half hour. तर maybe यो लामो हुन सक्छ. त्यसो हो भने चाहिँ we'll break and we'll then continue. So आजको मेरो एजेन्डा चाहिँ mostly artificial intelligence. What is AI? Then what is machine learning? अलिकति data science part अनि अलिकति deep learning को part छ. Then I will have some demonstration of AI and machine learning examples, real life examples out there. Then I will talk about the technology trends. What are the technology trends beyond 2030 or beyond 2028 or this year? So we'll be talking about those things. So, के हो त artificial intelligence भनेको? अहिलेसम्म तपाईले चाहिँ सेमिनार र सिम्पोसियममा बस्दाखेरि AI को बारेमा धेरै कुरा बुझिसक्नु भयो होला. मेबी तपाईले अलरेडी यसको नलेज छ होला. के हो त AI भनेको? तपाईं कफी पिउनुहुन्छ हैन? नेस्क्याफ कफी भेन्डिङ मेसिन छ. Do you think that machine is intelligent? No. Washing machine बुझ्नुहुन्छ तपाईले हैन? Washing machine ने तपाई चाहिँ intelligent machine भन्नुहुन्छ कि भन्नुहुन्छ? No. How many of you are no? Okay. किन washing machine चाहिँ intelligent हैन? Washing machine को basic functionality भनेको के हो? To wash the clothes, right? यसले कपडा धोयो भने यो intelligent भएन तपाईको विचार. तर त्यही कपडा तपाईले धुनुभयो भने you are intelligent. So AI को लेभल हुन्छ, right? So कपडा धुने machine is also an intelligent machine. तर त्यो इंटेलिजेन्सी अथवा त्यो लेभल अफ इंटेलिजेन्स चाहिँ कति छ भन्ने कुरा चाहिँ लेभल हामीले मेन्टेन गर्न सक्छौं, but we can say that is an intelligent machine. So if a machine makes you a coffee, that is AI. So it knows what to do. That might be basic functionality, but that is doing its job, right? So we can say that machine is intelligent. But if a machine makes you a copy of your taste, then that is machine learning. So to make a copy of your taste, it has to know your preferences, right? So if machine can learn your preferences, then we can say that it is machine learning, or the agent is intelligent, learn agent, right? So what are the functionalities of intelligence? I mean, केलाई चाहिँ artificial intelligence भन्छौं. Exact version of a man. भनेको मान्छेमा त्यस्तो के क्यापेबिलिटी छ जसलाई हामी इन्टेलिजेन्स भन्छौं. हामी मान्छे किन इन्टेलिजेन्स भयो? इन्टेलिजेन्ट भयो, राइट? It has capability of decision making, right? And it has capability of problem solving, and it has capability of learning. That makes a person intelligent. र हामी त्यही कुरा मेसिनमा गर्न खोजिरहेका छौं, and that is called artificial intelligence, right? Sorry, can I get the water? Sorry. You got the concept, right? So intelligence, artificial intelligence भनेको चाहिँ same human behavior, problem solving, decision making and learning. If we can mimic that on some script, some program or some bots, robots, then we say that is intelligent agent or intelligent system. So if you see the definition, It is the artificial intelligence is the automation of the activities that associates with human thinking. Those are the activities like decision making, problem solving, and learning. It's said by Bellman. So, जति पनि कुरा हामी एज अ ह्युमन गर्न सक्छौं त्यो कुरा हामीले कुनै बट अथवा प्रोग्राममा मिमिक गर्न सक्यौं हाम्रो क्यापेबिलिटीलाई चाहिँ ट्रान्सलेट गर्न सक्यो भने वी क्यान से दैट एजेन्ट अर दैट स्क्रिप्ट अर दैट फंक्शन अर दैट प्रोग्राम अर दैट मोडल इज अ इंटेलिजेंट मोडल, राइट? सो इफ यू सी सिम्पल एआई प्रब्लम्स, एउटा एक्जाम्पल के हुन सक्छ? सपोज यु आर अ फार्मर, राइट? र तपाईको चाहिँ खोला पार खेत छ र तपाई त्यहाँ खेती गर्न जानुहुन्छ र बेलुका तपाई घर फर्किनुहुन्छ एन्ड तपाईले चाहिँ घर फर्किँदाखेरि चाहिँ खेतबाट चाहिँ तरकारी लिएर आउनुहुन्छ, तपाईले एउटा बाख्रा पनि पाल्नु भएको छ र सोकको लागि चाहिँ एउटा वुल्फ पाल्नु भएको छ, स्याल पाल्नु भएको छ, राइट? सो टास्क इज टु गेट दिस थिंग्स अन द अदर साइड अफ द रिभर, भनेको खोला तार्नु पर्यो, तपाईसँग वुल्फ छ, गोट छ एन्ड क्याबेज छ. सो it is the AI problem. To solve it, we need to know the states and rules to follow. र यसमा restriction के छ भन्दाखेरि you can only row the boat. तपाई बोटमा एकजना मात्र चलाउन सक्नुहुन्छ, तपाई मात्र चलाउन सक्नुहुन्छ र त्यहाँ एकजना एउटा अर्को आइटमको लागि मात्रै ठाउँ छ. र अर्को restriction के छ भन्दाखेरि you cannot leave something that is that it's another item. I mean, कुनै त्यस्तो आइटम चाहिँ सेम बैंकमा राख्न सक्नुहुन्न, सेम किनारमा राख्न सक्नुहुन्न, जल्दी अर्कालाई खान्छ, जस्तो स्याल र बाख्रा सँगै छोड्न सक्नुहुन्न, बाख्रा र क्याबेज सँगै छोड्न सक्नुहुन्छ. So this is AI problem. To solve this, you need some thinking, some decision making, some learning thing that can solve this problem. So this is a simple AI problem. So it do not requires machine learning. It just requires some rules to process and it will solve, right? So another problem, AI problem can be this monkey and banana problem. एउटा रूम छ, रूमको बिचमा चाहिँ बनाना झुन्डिरहेको छ, भनेको सिलिङमा बनाना झुन्डिरहेछ, केरा झुन्डिरहेछ. र अब एउटा बाँदर चाहिँ ढोकाबाट भित्र पस्यो. अब त्यो बाँदरले चाहिँ त्यो केरा चाहिँ खानु पर्यो. अब हामीले बाँदरलाई केरा खान सिकाउनु त हैन, बट टास्क इज उसले चाहिँ सिम्पली चाहिँ त्यो ग्रास्प गर्न सक्दैन. त्यहाँ चाहिँ बक्सहरु छ, त्यो बक्सलाई चाहिँ सेन्टर अफ द रुममा लगेर राखेर त्यसमाथि चढ्यो भने मात्रै बाँदरले केरा खान सक्छ. सो दिस इज एआई प्रब्लम. एज अ ह्युमन और monkey can solve this problem very easily, but for machines to solve this we need to follow certain states, certain steps, certain rules, and then we can get solution of this, right? पहिले चाहिँ बक्सलाई चाहिँ सेन्टरमा लिएर आउने, त्यसमाथि चढ्ने अनि ग्रास्प गर्ने खाने, right? So those are the things, simple AI problem. So talking about the AI problems, अब AI भने कस्तो हुन्छ त? Mainly the AI is of three types. First is narrow AI अथवा weak AI भन्छौं, जुन चाहिँ अहिलेको एरा नै हामी weak AI मै हो. We still on very basic and narrow AI. भनेको जुन काम गर्नको लागि हामीले मोडल ट्रेन गर्छौं अथवा फंक्सन लेख्छौं त्यसले त्यति मात्रै काम गर्छ. It do not know about anything else. It is not generalized system that knows everything. So it is very narrow thing. So as I said, for washing machine, if washing machine can wash your clothes, that is weak AI or basic AI or narrow AI, you can say, right? अहिलेसम्मको जति पनि मोडल, इभन जीपीटी मोडलहरु जुन आइराछ, those we say as a narrow AI. So next is strong AI or general AI. General AI भनेको चाहिँ यो वर्ल्डको एभरेज मान्छे जतिको नलेज भएको एजेन्ट, that is general AI. We are not yet to there, right? Next is super AI. You can say God or superhuman. एउटा मोस्ट इन्टेलिजेन्ट मान्छे पृथ्वीमा भन्दा बढी इन्टेलिजेन्ट कुनै एजेन्ट बनाउन सक्यो हामीले भने we can say that a super AI. Sorry. So what is the machine learning then? You know the AI, right? So what is the machine learning then? Machine learning is a concept, अथवा you can say a model. त्यसले चाहिँ डेटा र आउटपुटको आधारमा चाहिँ मोडल बनाउँछ अथवा प्रोग्राम चाहिँ अटोमेटिकली जेनेरेट गर्छ. That is machine learning. ट्रेडिसनल वेमा के हुन्थ्यो भन्दाखेरि we feed the data, we know what to program to fit or what program fits that data. Manually हामीलाई त्यो थाहा हुन्थ्यो र we try to feed that program into that data र त्यसपछि चाहिँ हामी एक्स्ट्रापोलेट गरेर इन्टरपोलेट गरेर चाहिँ आउटपुट अननोन इन्भाइरोमेन्टमा आउटपुट लिन सकिन्थ्यो. बट मेसिन लर्निङ कन्सेप्ट इज डिफरेन्ट कन्सेप्ट. वी नो द डेटा एन्ड वी नो द आउटपुट. नाउ एप्रोच अर द थिङ इज टु नो द प्रोग्राम, टु नो द मोडल. द्याट इज द मेसिन लर्निङ. डेटाहरूबाट चाहिँ प्रोग्राम आइडेन्टिफाई गर्नु अथवा प्रोग्राम जेनेरेट गर्नु इज ए मेसिन लर्निङ. सो देयर आर बेसिक कन्सेप्ट अफ machine learning, that is induction. Machine learning system or agent or program can induce something and then generalization. Induction and generalization is the core concept of machine learning. Suppose if we say person A from Nepal is an actor, right? Person B from Nepal is a singer and person C from Nepal is a musician. So what can you generalize from there? So you can say these are the training examples, these are the contexts. So we can generalize and make one machine learning model. We can say most of the Nepalese are talented, right? So we can generalize from lots of data. That is basically machine learning. So what is data science then? Data science is a science of making data intelligent or data useful, right? You can see data भने त धेरै टाइपको डेटा हुन्छ. ट्रान्सपोर्ट डेटा, जियोग्राफिकल डेटा, कल्चरल डेटा, साइन्टिफिक डेटा, राइट, statistical data, meteorological data, right? So these data, if we can get some insights on these data, then we can say that is a data science. Suppose तपाईहरुसँग चाहिँ ट्रान्ज्याक्सन हिस्ट्री छ. बेस्ड अपन ट्रान्ज्याक्सन हिस्ट्री, बैंक स्टेटमेन्ट, you can, if you can identify who are the most genuine customers, who are the most valuable customers, what is my monthly revenue, what is my expenditure. So those are the data science part. So if you see data, this is a very latest stats from demo.com. So यसले के भन्छ भन्दाखेरि in a single minute of a day, what amount of data people are uploading, downloading from the internet, or what are the internet minute data. So तपाईले हेर्नुभयो भने स्न्यापच्याटले चाहिँ 2.4 million snaps per minute चाहिँ पोस्ट गरेर हुन्छन् स्न्यापच्याट, राइट? सिमिलरली इन अ ट्विटर 347k tweets every minutes are there. So र यो स्ट्याट भनेको अल ओभर द सोशल मिडिया प्लेटफर्ममा तपाईले देख्न सक्नुहुन्छ. र इफ यु सी द ट्रेन्ड, we say data never sleeps. This is the concept by demo. So it says data never sleeps. If you see in past 10 years, हामीले चाहिँ जुन डेटाको ग्रोथ देखिरहेका छौं, that is increasing order, that is not settled and sleeps. So data is increasing day by day. And if you see the internet volume, over 63% of the world population is on internet. So internet is almost 5 billion people so far, right? र त्यसमध्ये पनि तपाईले हेर्ने हो भने 4.65 billion चाहिँ अथवा 93% चाहिँ सोशल मिडियामा छन्. So people are interacting with internet, generating data. So now thing is to know, to identify or to get insights from these data. That is data science part. Okay. So if you see the types of machine learning, I will not go very deep on this. So we have pretty three kind of machine learning approaches. So supervised machine learning, that is where you give the target labels along with your data. You know what the output is already. And there is unsupervised learning. So where you don't know the output, you just cluster data, you aggregate features and classify things according to some prominent features on the input data. And there is reinforcement learning. Reinforcement learning is acting on the environment, and based upon your action on the environment will reward you or punish you and based upon that reward and punishment, you will keep learning. So that is the concept of reinforcement learning. So these are the very basic 3 types of machine learning approaches. I mean, so far and beyond, we will be using these types only. र अब हामीले चाहिँ मेसिन लर्निङ चाहिँ के गर्न सक्छ त, मेसिन लर्निङबाट हामीलाई के फाइदा हुन्छ त भन्यो भने वी क्यान सी सिम्पल एक्जाम्पल. सपोज देयर इज अ पिक्चर. अब पिक्चरबाट चाहिँ हामीले के चाहिँ इन्साइट लिन सक्छ त? टास्क क्यान बी आइडेन्टिफाइङ अर डिटेक्टिङ ह्युमन फेसेस अर फाइन्डिङ फेसेस. र यसको एप्लिकेसन चाहिँ फोटो ट्यागिङमा हुनसक्छ अथवा फेस रिकग्निसन टेक्नोलोजीमा हुनसक्छ. जस्तै हामीसँग इनपुट चाहिँ लोन एप्लिकेसन छ, कसैले चाहिँ घरको लोनको लागि चाहिँ एप्लाई गर्यो कुनै ब्याङ्कमा भने यसको रिस्पोन्स हामीले चाहिँ के हुनसक्छ कि इज दिस लोन क्यान बी पेड इन रियल टाइम अर आई मिन पेड फाइनली अर यो चाहिँ डेप्ट जान सक्छ त ब्याङ्कको लागि भनेर. सो द्याट क्यान बी लोन एप्रुभल. अर्को चाहिँ तपाईँसँग एडको डेटा छ भनेपछि द रिस्पोन्स इज टार्गेट चाहिँ तपाईँलाई कुन एड गर्न सकिन्छ, कुन प्रोडक्ट गर्न सकिन्छ भन्ने कन्सेप्ट हुनसक्छ. त्यस्तै अडियो क्लिप एज ए इनपुट छ भनेपछि यु हेभ लाइक ट्रान्सक्राइबिङ दोज अडियो इन्टु सम टेक्स्टुअल फर्मेट, मेबी फर स्पिच रिकग्निसन अर बेटर सर्चिङ द अडियो. अर्को भनेको चाहिँ तपाईँले चाहिँ ट्रान्सलेसनको एउटा टास्क हुनसक्छ जसमा चाहिँ इनपुट चाहिँ इङ्ग्लिस सेन्टेन्स छ र टार्गेट चाहिँ एनी फ्रेन्च अर नेप्ली सेन्टेन्स. देन task is to convert that into destination language. So that is also a machine learning thing it can do. And there is like sensor data, IoT device or some device or what data. त्यसको चाहिँ हामीलाई रिस्पोन्स के चाहियो कि त्यो बेस्ड अपन दैट डेटा आइदर दैट सिस्टम फेल्स अर नट, मेबी प्रिभेन्टिभ मेन्टेनेन्समा वी क्यान युज दैट. अर्को चाहिँ कार सेन्सरहरू अथवा तपाईँको क्यामेराहरूको डेटा, त्यसले के हामीले के चाहिँ त्यसको आउटपुट हामीले खोजिरहेको भन्दाखेरि व्हाट इज द पोजिसन अफ कार, क्यान आई डु अटोनोमसली अर नट, दोज काइन्ड अफ एप्लिकेसन क्यान बी विथ दिस मेसिन लर्निङ. सो मेसिन लर्निङ क्यान डु लट्स अफ थिङ, यू क्यान से एभ्रिथिङ. So what is deep learning then? So deep learning is nothing but machine learning with neural networks. Our neural networks भनेको चाहिँ के हो भन्दाखेरि this is the concept like mimicking the human brain. मान्छेको ब्रेनले चाहिँ जसरी काम गर्छ सेम प्याटर्नमा सेम कन्सेप्टमा चाहिँ तपाईको न्युरल नेटवर्कहरुले काम गर्छ. त्यही न्युरल नेटवर्कको डेन्स आर्किटेक्चरहरुलाई ट्रेन गर्ने टेक्नोलोजी इज डीप लर्निङ. It is training on big data. So we talk about big data and deep learning most of the time. अहिले चाहिँ machine learning भन्ने बित्तिकै मान्छेहरूले त्यो simple AI, rule based AI अथवा हाम्रो normal machine learning traditional approach बुझ्दैन. अहिले हामीले बुझ्ने भनेको चाहिँ deep learning and big data. So it is inspired by the structure and function of the human brain. र classical machine learning approach मा के हुन्छ भन्दाखेरि you have to engineer the features. इनपुट स्पेसको चाहिँ फिचरहरु चाहिँ तपाईले आफैले म्यानुअली चाहिँ इन्जिनियर गर्नुपर्छ. देन ओन्ली यू क्यान फिड दैट डेटा इन्टु सम मशीन लर्निङ मोडल, राइट, एन्ड यू विल गेट द आउटपुट. बट विथ डीप लर्निङ व्हाट हैपेंस इज दैट feature representation is hierarchical and automatic. You do not have to explicitly extract features and feed to the neural network, but it will automatically do that on behalf of you. So that is a deep learning thing. Okay, so a little bit mathematics behind machine learning. So mathematics त के हो त? कसैले तपाईलाई सोध्यो भने चाहिँ you can say कि minimizing the error between target and your predicted value. That is the machine learning. भनेको minimizing the loss between this y is target output and x given theta is the function or model, right? Minimizing the loss between target and predicted value for given theta parameters and input x, and that is summed over all training samples. If you can minimize that, then we say this is learning, this is machine learning. So pretty simple. So okay, so if you see the pipelines, what are the machine learning pipelines? So कसरी machine learning चाहिँ हामीले achieve गर्छौं त? यो कुरा अलरेडी पनि आइसकेको छ. जस्तो जनक सरको केसमा पनि उहाँले टाइम सिरिजमा थुप्रो डेटा प्रोसेसिङको कुराहरु गरिसक्नुभएको छ. सरी, इट इज नट मुभिङ. क्लिक त गरे एटै गर्छ चलिरहेछ सर यहाँ चलिरहेछ यसमा साउन्ड आयो साउन्ड यताको बेटा गरौँ हुन्छ र त्यहाँ यहाँ डेटा चलाउनु पर्दा पनि प्रोग्राम चाहिँ मसँग सल्लाह भइहाल्छ कुन भन्नु भिभो उसको कनेक्ट हुन्छ कता हाल्न जान्छ ल्यान्ड चलेछ उता त त्यही ल्यान्ड फेरि यता ल्यान्ड त्यही हो यसमा के वाइफाई जुम चाहिँ कनेक्ट हुनु कता हो होइन नि राजन सर जुम हल्यो जुम नै हटिसक्यो फेरि जुमलाई फेरि सुरुबाट गर्नु यसरी हान्नु त राजन सर एउटा आइडी ट्याग जेनेरेट गरेर पठाउनु भयो सजिलो हुँदैछ
यसको त हेरि अघि यहाँ थियो नि एउटा लिङ्क हाम्रो रजिस्ट्रेसन फेरि गर्नु एकपल्ट टाइप गरेर
पर्दैन इन्डस्ट्री छैन Okay, continuing. So machine learning pipeline here as we said, as Janak sir said, it has pretty similar components like data pre-processing and then middle layer feature engineering, then model training and evaluation, then model deployment and prediction. So every machine learning things go in this pipeline. So we have training data, then we pre-process the data and labels, then we do feature engineering, then we calculate features. Features are some mathematical representation of that input space, and then we select some machine learning approach, we train it, we evaluate it, and save that trained model somewhere in persistent volume. Then at the prediction time, we load that persistent model and provide the test data or real-time data and get the prediction and inferences. So if you see for computer vision, the pipeline will be same, but components or the components models are different. Like तपाईले चाहिँ डेटा हुँदाखेरि चाहिँ इमेजको केसमा चाहिँ जस्तो क्याट र डग छ र लेबल्स इज टु आइडेन्टिफाई or classified as a cat or dog. र अब यसको चाहिँ फिचर इन्जिनियरिङमा चाहिँ प्री प्रोसेसिङमा चाहिँ अब त्यो इमेजलाई चाहिँ फाइन्ड गर्ने कुरा, वास गर्ने कुराहरू भयो. त्यसपछि इन्जिनियरिङमा चाहिँ अब त्यो इमेजबाट चाहिँ जस्तो कलरहरु डिटेक्ट गर्ने, लाइन डिटेक्ट गर्ने अथवा तपाईको शेडहरु डिटेक्ट गर्ने, बेसिक अब्जेक्टहरु शेपहरु डिटेक्ट गर्ने कुराहरु चाहिँ हुन सक्छ मेबी फर सिम्पल सेइङ। र त्यसपछि मेसिन लर्निङ एप्रोच, वी क्यान से एनी मेसिन लर्निङ एप्रोच लाइक एसपीएम, डिसिजन ट्रीज, रिग्रेसन, any one, and then we can do machine learning. So if you see for NLP, it is the pretty same pipeline, but the component models or component functionalities is different. Input ma chahi tapaiko text document athwa text, र output ma chahi maybe class हुन सक्छ corresponding. यसको आफ्नो प्रिप्रोसेसिङ हुन्छ, जस्तो स्टप वर्डहरु हटाउने अथवा तपाईको अननेसेसरी चाहिँ डेटा छ, नोइजी डेटा छ भने वाशिङ दैट, क्लिनिङ दैट। And then feature engineering ma chahi jasto त्यो टेक्स्ट चाहिँ कति चोटि अकर भएको छ, what is the POS tag, what is the frequency, those kind of thing we can analyze as a feature. Then we translate that into mathematical representation and then provide to machine learning model. So machine learning model is generic that can be used for it will be same for even computer vision or NLP tasks, but data will be different, and based upon data it will learn, right? Okay, that is the first part where I talk about more what is AI, what is machine learning, deep learning, simple things, and data science things, right? So now I will be moving toward the applications, real life application. You can see with me now. So one example can be news classification, clustering, or tagging. So here the task is to classify the news or classify any text into some predefined class or cluster similar types of news or tag the news. Task भनेको जस्तो के हुन सक्छ कि भोलि चाहिँ मानौ गभर्नमेन्टले चाहिँ प्रधानमन्त्रीको बारेमा चाहिँ कस्तो कुराहरु हुन्छ त सोशल मिडियामा भन्ने जान्न खोज्यो भने we can apply this NLP thing, and this is one example of AI. And the thing is fake news identification. To know the news is fake or real, we can apply AI tools, AI algorithms, and identify it. Identify junk news, pseudo news, or hoax news, right? To identify this, we can analyze the source, author, date of publishing, either it is joke or not, those kind of things, right? So another example is summarization. This is, I mean, I have written back 2017. So it is the concept is summarizing the large amount of text into some sentences of single paragraph, maybe 5%, 10% of total sentences. So that will preserve the semanticness in the input and give us the abstract of the text. That is one example. So, and there is sentiment analysis. Suppose if somebody says that what are the sentiments of my organization, people are talking in internet or in social media, then I can know those things, right? Maybe Twitter ko chahi hamle data herera, what are the people talking about my business? We can know that, and based upon that, we can make decisions and get ideas, right? So, under technology or another example of AI is OCR. Or OCR is optical character recognition, that is printed character recognition, handwritten character recognition, and next term is intelligent character recognition. So that is the combination of both ICR and OCR. So this is part of my thesis in back 2012, I think. So it's been 13 years I've been working full-time on machine learning and AI field. Right. So here task is to convert that printed text or handwritten, typewritten text into some readable, editable format. So use cases might be like document digitization, text extraction, data entry, personal note processing, form processing, handwritten text analysis, or personalized correspondence. We can say which has written these notes maybe. So there are other tools available online freely, so open source tools, right? So under AI example is object detection, classification, and segmentation. So I just group the title, but यसमा चाहिँ तपाईको object detection, classification, segmentation का एउटा आफ्नै सेमिनार अथवा आफ्नै टक हुन सक्छ हैन. So there are lots of things we can do with these technologies. So it is AI example. AI application, you can say, where maybe like face detection, generic object detection, and then maybe scene detection or pedestrian detection, then maybe cars, vehicles detection, and many more things. So classification is basically a classifying the input image into some predefined class. So you do not do not care about where that particular object falls in that image, but just to classify the input into some predefined class. You can see in first image there. So, and there is detection. Detection is basically a localization plus classification. So it also knows where that object lies on the image. So that is detection basically. And another is segmentation. Segmentation is finding the exact boundary of the object. It is either semantic segmentation or instant segmentation. Semantic segmentation भनेको चाहिँ जस्तो मैले चाहिँ क्याटहरूलाई चाहिँ सेगमेन्ट गर भन्यो भने चाहिँ it will only segment cats. But instant segmentation भनेको चाहिँ it will segment every cats, right? Those kind of thing. So its uses can be like autonomous vehicles. We know road situations, what are moving in object or dynamic objects based upon the camera input, sensor inputs, so that it will help in autonomous driving, right? So under is autonomous robots. Next might be surveillance and security. Maybe face recognition system can go for access control, surveillances, right? Monitoring. Next might be retail and inventory management, where you can automatically sort the inventories and know what's are in the stocks, what's not, what is the purchasing time, those kind of things. And medical imaging. So you can know from chest x-rays or some reports, maybe cancer cells can be detected. Those kind of thing can be done with this technology. So quality control, content filtering, like suppose अहिले चाहिँ हाम्रो सेन्सर बोर्डले चाहिँ तपाईको मुभी हेरेर चाहिँ त्यहाँ कुनै सिन काट्नुपर्छ भने it will go through manual process, right? That can be automated. Some we will make certain rules कि यो object अथवा यो content चाहिँ यो उसमा हुनु हुँदैन भन्यो भने we can filter that automatically. We can flag that automatically, right? That kind of filtering, image editing and augmentation, and VR AR thing. So next is face recognition. So that is the technology to recognize yourself in mass, or you can say at billion people. So मैले यो slide किन राखेको भन्दाखेरि यो म continuously 2014 बाट राख्दै आएको छु. मैले कुनै पनि प्रेजेन्टेसनमा मैले AI टक दिँदाखेरि, because when we started back in 2014, deep face technology अथवा त्यो अल्गोरिदम चाहिँ फेसबुकले चाहिँ ओपन सोर्स गरिदियो. त्यसपछि चाहिँ मान्छेहरूले फेस रिकग्निसन पनि हुन्छ, वी क्यान गो अन मास भन्ने कुरा थाहा पाए. एट द टाइम वी स्टार्टेड विथ C++, MATLAB काइन्ड अफ थिङ, र त्यो हामीले एचिभ गर्न चाहिँ कोसिस गर्थ्यौँ. एन्ड अहिले चाहिँ यो फेस रिकग्निसन भन्ने त्यस्तो चर्चाको विषय नै छैन. त्यसपछि लगत्तै 2015 मा चाहिँ गुगलले चाहिँ फेसनेट भन्ने मोडल ओपन सोर्स गर्यो. टिल नाउ वी आर मोस्टली युजिङ दोज टेक्नोलोजिज. It is de facto भइसक्यो कि most of the use cases, or we are already कसैको निगरानीमा हामी अलरेडी छौँ. People are monitoring us. र अब म टाइम भयो भने I will show you one real example that we are doing face attendance in our office passively. भनेको चाहिँ कसैले क्यामेरामा हेर्नै पर्दैन. We can track every employee. You can know when gets in, when goes out, what check-in time, what check-out time, right? So another example might be automatic automatic machine translation. Either this can be text to text translation or image to image translation. यो भनेको चाहिँ युज केस कहाँ हुन सक्छ भन्दाखेरि, मानौ म चाहिँ विदेशमा घुम्न गए, I don't know the language, तर मैले चाहिँ स्ट्रीट साइनहरु पढ्नु पर्यो, बोर्डहरु पढ्नु पर्यो भने, if I can translate that to my language, that will be easy, right? That can be for Nepali language or Nepali scenes board also. So this is one AI example. So under is speech recognition. That is transcribing the speech into text, or we can say recognizing the speech and then doing corresponding intent things. Sorry, sir. Continue. It will take little bit time. Okay. Okay. Okay, continuing. So अब मैले स्पीच रिकग्निसन को बारेमा धेरै भन्नु परेन. You already have ideas on this and how it works actually. So it is just translating your voice into textual format. र त्यो textual format can be used for many things, maybe documentation purpose or some intent classification and doing certain things, right? Like personal assistant kind of thing. Okay, next is image caption generation. So अब सुरुमा जति बेला यो टेक्नोलोजी आएको थियो त्यति बेला हामीले यसलाई रमाइलोको लागि चाहिँ स्लाइडमा राख्ने गर्थ्यौं, बट नाउ इट हेज लट्स अफ आइडियाज एन्ड इट हेज लट्स अफ युज केसेस. भनेको इमेजलाई डिस्क्राइब गर्नु पर्यो, इमेज टु टेक्स्ट, राइट? You can your technology can be used for blinds or describing the text, or you can say writing transcript from videos. Those kind of things can be done, or reverse texting, you can say, that can be done with this technology, right? So it will clearly or very efficiently describe the image, a group of people shopping in an outdoor market, right? So it will describe your input image. That is the AI technology. So if I mean, as I say AI, it is AI, machine learning, and deep learning. So you think like that, okay? So next is sketch drawing. अब जति बेला यो टेक्नोलोजी आएको थियो, we just keep 2017 तिर हामीले चाहिँ अब यसलाई रमाइलोको लागि चाहिँ स्लाइडमा राख्थ्यौं, but it has lots of use cases, right? मैले चाहिँ केही कुरा सुरु गरे भने it will complete that sketch. मैले चाहिँ घर बनाउन सुरु गरे भने I just draw outline and it will then complete it. So it will get new ideas. It will be used for artistic purposes, like, right? म म्युट थिएँ अहिलेसम्म. So it is saying unmute. What is this? Hello. Okay. So next is image to text to image synthesis. भनेको चाहिँ तपाईले गिवन टेक्स्टलाई चाहिँ इमेजमा कन्भर्ट गर्ने र अहिले चाहिँ रिसेन्ट एडभान्समेन्टमा चाहिँ विथ एआई टेक्नोलोजी एन्ड डिप लर्निङ, अल दोज थिङ्स, इट इज प्रिटी एक्युरेट र इट इज डिस्क्राइबिङ or it is generating images pretty well. अब अहिले चाहिँ available 2-3 models are there, like Dalle E2 image gen from Google Brain. Dalle E2 चाहिँ हाम्रो OpenAI को भइहाल्यो, Google Brain को image gen, र त्यसपछि अर्को छ stable diffusion भन्ने, stability AI को. अब यसमा चाहिँ हामीले एउटा प्रम्प्ट हेर्ने हो भने चाहिँ राइट साइडमा मैले दुईटा एक्जाम्पल लिएको छु, एउटा डल्ले ई को र एउटा चाहिँ स्टेबल डिफ्युजन को. र फर्स्ट पिक्चरमा चाहिँ यसले के भनेको छ कि टेडी बियर चाहिँ जुन 1990 को टेक्नोलोजी युज गरेर चाहिँ एआई रिसर्च गर्न खोजिरहेछ, गिभ मी दैट इमेज भनेर मैले एउटा टेक्स्ट आइडिया दिए एन्ड द मोडल गिव्स मी दिस रिजल्ट. सो इट इज प्रिटी प्रोमिसिङ, राइट? र नेक्स्ट इमेज चाहिँ तपाईले हेर्न सक्नुहुन्छ. द प्रम्प्ट इज, मैले चाहिँ मोडललाई के भने भन्दाखेरि ड्र एन इमेज with like an astronaut riding a horse by Hirosigi. So Hirosigi भन्ने चाहिँ जापानिज आर्टिस्ट हुनुहुन्छ, उहाँले बनाए जस्तै इमेज चाहिँ मलाई बनाएर दे भने it generates pretty well. If you see Hirosigi's art, it will be pretty similar, right? So those are the advancement and AI examples of text to image generation. So under is handwriting generation. यो भनेको चाहिँ तपाईले इनपुट इमेज के अरे इनपुट टेक्स्ट दिनुभयो भने it will generate handwritings for you. So यसको युज चाहिँ मेबी एकाडेमिक्समा हुन सक्छ अथवा पुरानो म्यानुस्क्रिप्टहरुलाई चाहिँ रिराइट गर्नको लागि हुन सक्छ अथवा नयाँ फन्टहरु डिस्कभर गर्नको लागि हुन सक्छ. So it might have lots of use cases. So it is one another example of AI. So under is text generation. So अब तपाईले चाहिँ GPT-3, GPT-4 अथवा च्याट GPT भन्यो भने मैले धेरै डिस्क्राइब गरेर राख्नु पर्दैन, but the idea behind that model is generating the output text. It is just generating the text based upon your input context. It is generating the output. र त्यो कुरा चाहिँ हामीले चाहिँ धेरै युज केसहरुमा युज गर्न सक्छौं अहिले चाहिँ तपाईले चाहिँ डिसिजन सपोर्ट अथवा तपाईले चाहिँ लेख्दाखेरि त्यहाँ चेटमा हेरेर फर्दर प्रोसेस गर्नुहुन्छ त्यसलाई युज गर्नुहुन्छ हैन दैट क्यान बी अटोमेटेड भनेको त्यो जेनेरेटेड टेक्स्टलाई पनि हामी सम युज केस स्पेसिफिक बनाउन सक्छौं मेबी लाइक कन्टेन्ट क्रिएसन च्याटबोट्स एन्ड भर्चुअल एसिस्टेन्ट सो जस्तो च्याटबोट्स अथवा भर्चुअल एसिस्टेन्टले चाहिँ हामीले भनेको इन्टेन्ट थाहा पायो भने इट क्यान जेनेरेट responses based upon that. If I say suppose transfer a money between from bank account A to bank account B, then it will know, it will understand that and then do the necessary things, right? So similar like data reporting and insights. मसँग चाहिँ structured data छ भनेपछि this GPT thing or generative text model can generate reports from that data. Personalized messaging. मेरो पर्सनल इन्टेन्ट अथवा कन्टेक्स्ट को आधारमा चाहिँ मेरो जस्तै उसले चाहिँ रिस्पोन्सहरु जेनेरेट गर्न सक्छ अथवा मेरो बिहाफमा कुरा गर्न सक्छ त्यस्तै ट्रान्सलेसन भइहाल्यो स्टोरी टेलिङ नरेटिभ जेनेरेसन पोएट्री एन्ड क्रिएटिभ राइटिङ अब तपाईले मानौ शेक्सपियर त हामीसँग हुनुहुन्न अब शेक्सपियरको जति पनि लेखेको पोइमहरु छ हामीले त्यो मोडललाई चाहिँ लर्न गराछौं भनेपछि तपाईले चाहिँ भोलि कुनै मलाई चाहिँ शेक्सपियर स्टाइलमा चाहिँ एउटा नयाँ पोइम लेख भन्यो भने इट विल राइट फर यु कन्टेन्ट समराइजेसन अघि मैले कुरा गरिसके लर्निङ ल्याङ्ग्वेज लर्निङ एन्ड एजुकेसन भनेको नयाँ कुरा लर्न गर्नु पर्यो भने इट विल बी मोर एब्स्ट्र्याक्टिभ एन्ड गिव्स यु द एक्ज्याक्ट थिङ एन्ड यु क्यान लर्न बेटर एन्ड डायलॉग सिस्टम्स एन्ड गेमिङ. So next is code generation part. So it can automatically generate code. र अब तपाईले हेर्दै जानु होला 2-3 वर्ष अथवा 4-5 वर्षपछि लेट्स से 2030 पछि चाहिँ अब सफ्टवेयर कम्पनीहरुले चाहिँ सफ्टवेयर डेभलपर भनेर भ्याकेन्सी नै अनाउन्स नगर्न सक्छ बिकज एआई थिङ इज राइटिङ कोड फर यु यु हेभ जस्ट ट्रान्सलेट आइडियाज यु हेभ जस्ट से व्हाट टु डु देन एआई सिस्टम क्यान राइट कोड फर यु and it will be pretty compilable, pretty deployable code and full code. Already you धेरै लेभलसम्म out there, right? त्यस्तै autonomous driving मा त मैले भन्नै परेन unmanned vehicle, so it will sense the environment and find the next mode or calculate next moves automatically so that it can navigate in different paths, dynamic paths, right? So AI technology can do this. This is one, I mean, very big AI example, use case. अब त्यहाँ अहिलेसम्म हामीले हेर्दाखेरि वाइमो भन्ने छ टेस्ला भइहाल्यो हैन गुगलको आफ्नो इन हाउस सेल्फ ड्राइभिङ कारहरु छ नेभ ल्याबको आफ्नो सेल्फ ड्राइभिङ भेहिकलहरु छ सो दिस कम्पनीज or these industries are using AI for this autonomous driving. So and there is a game playing हामीले अलरेडी थाहा होला हैन जस्तो 1996 तिर हो सायद हैन ग्यारी क्यास्क्रोभ जुन चाहिँ हाम्रो चेस च्याम्पियन हुनुहुन्थ्यो उहाँलाई चाहिँ डीप ब्लू भन्ने कम्प्युटरले चेसमा हराएको सो एआई इज दैट पावरफुल एट दैट टाइम टु बट अहिले आएर हेर्दाखेरि तपाईले यो 2017 तिर होला यो ली सिडेल भन्ने चाहिँ गो को च्याम्पियन उहाँलाई चाहिँ अल्फागो भन्ने गुगल ब्रेनले बनाएको प्रोग्रामले चाहिँ हराएको सो इन गेमिङ अल्सो अटोमेटिङ गेम प्लेइङ एन्ड रिकमेन्डेसनमा अब मैले यसमा त भन्नै परेन हैन इफ यु गो इभन इन दराज और अमेजन एनी प्रोडक्ट और एनी ई-कमर्स साइट्स यु विल सी दिस रिकमेन्डेसन्स एज पर युर प्रिफरेन्सेस एन्ड दैट इज अल कमिङ थ्रु दिस एआई टेक्नोलोजी. So next is entertainment. अरु कुरा भन्दा पनि if you see the TikTok is a personalized TV. So it will just recommend you based upon your preferences. So it is both collaborative filtering भनेको चाहिँ तपाईको चाहिँ सिमिलर युजरहरु चाहिँ फाइन्ड गर्ने अनि त्यो सिमिलर युजरको कन्टेन्ट चाहिँ मलाई चाहिँ शेयर गर्ने जस्तो मैले चाहिँ कुनै कन्टेन्ट हेरेको छैन तर मसँग सिमिलर डेमोग्राफिकली सिमिलर अथवा कुनै एट्रिब्युटबाट सिमिलर युजरले चाहिँ त्यो कन्टेन्ट हेरेको छ भने त्यो कन्टेन्ट मलाई रिकमेन्ड गर्ने दैट इज कोलाबोरेटिभ फिल्टरिङ. अर्को चाहिँ कन्टेन्ट बेस भने चाहिँ जस्तो मैले चाहिँ कुनै एउटा भिडियो हेरे र त्यसको कन्टेन्टसँग सिमिलर कन्टेन्ट भएको अरु भिडियो मलाई रिकमेन्ड हुन्छ. दोज आर द रिकमेन्डेसन टेक्नोलोजिज एन्ड दोज आर अगेन एआई एप्लिकेशन्स. So last but not the least, robotic process automation. अब अहिले यो धेरै नै तपाईको हाइपमा आएको कुरा छ। तपाईले चाहिँ रोबोटिक प्रोसेस अटोमेसन भन्ने टर्मिनोलोजी राइट। यसमा चाहिँ सफ्टवेयर अटोमेसन अथवा जुन म्यानुअल जुन म्यानुअल टिडिएस टास्कहरु छ that can be automated with AI and scripts right. अब यसमा मेबी लाइक डेटा एन्ट्री एन्ड भ्यालिडेसनको कुराहरु हुन सक्छ। त्यसपछि इनभोइस प्रोसेसिङको कुरा हुन सक्छ। यो भनेको चाहिँ जस्तो मैले चाहिँ कुनै थर्ड कम्पनीमा काम गर्छु, मैले चाहिँ मन्थली इनभोइस पठाइराख्नु पर्छ। बट इनभोइस हैज इट्स ओन फर्मेट राइट। आई राइट सब्जेक्ट, आई राइट अमाउन्ट, डिस्क्रिप्सन, अल दोज थिङ्स। र त्यो कम्पनीले मलाई चाहिँ अब मेरो इमेलको अथवा मेरो पिडिएफको आधारमा चाहिँ मलाई पे ब्याक गर्नुपर्छ। सो दैट company can use this invoice processing technology or automation technology so that it will automatically extract information from that PDF invoice and knows the amount, knows where to send money, how much money to send, then it will send automatically. Customer onboarding. Sorry. मानव ब्याङ्किङ सेक्टरको कुनै एक्जाम्पल छ भने मलाई चाहिँ ब्याङ्क एकाउन्ट खोल्नु पर्यो भने that is pretty same for all right. So there are pretty same steps to follow that can be automated. Report generation, HR and employee management, IT operations, claims processing. मैले चाहिँ इन्स्योरेन्समा कुनै क्लेम गरे भने that can be processed automatically based upon my history, my other profile data and decide either that claim is valid or legitimate or we can process or not. We can decide that automatically. Data migration, supply chain management, like तपाईले चाहिँ मानौ डेलिभरी सिस्टमको कुराहरु गर्नुपर्छ भने most of the delivery अथवा supply chain management can be automated right. अर्डर लिनेदेखि लिएर सिपमेन्टको कुराहरुदेखि लिएर त्यो शेड्युल गर्ने कुरादेखि लिएर मार्किङ अर्डर्स कम्प्लिट अर फुलफिल्ड काइन्ड अफ थिङ क्यान बी डन अटोमेटिकली. Compliance and audit, etc. So those are the more on AI examples. Next, I'll be moving with AI ML trends, right? So little bit our time लिन्छ होला. So do I have time? छैन के गर्ने नत्र हामी यसलाई चाहिँ ब्रेक गरेर अर्को सर्कल लिएर फेरि कन्टिन्यू गर्न सक्छौं। यसमा थोरै राम्रो कुराहरु पनि छ। तपाईलाई चाहिँ नयाँ टेक्नोलोजी के हुन्छ भनेर मेबी बोर त तपाई अलरेडी भइसक्नु भयो हो। ओके म एकदमै फास्ट पिसमा गइरहेको छु किनकि मसँग टाइम नै धेरै लिमिटमा राखिदिनु भएको छ कि इट इज मोर 1.5 आवर प्रेजेन्टेसन। के गर्ने त यसले पछि गर्ने। Okay, we'll be continuing this AI ML trends. So it will be again fun. र हामी अहिले चाहिँ अर्को एकजना प्रोफेसरको चाहिँ टक सुनाउँ त हुन्छ।
Thank you, sir. We will continue that later. Joining us now is an assistant professor in computer science and engineering, CSC department at IIT Kanpur. His research areas include natural language processing, machine learning, and artificial intelligence. He will be joining us via online platform Zoom. Please give a warm welcome to Dr. Ashutosh Modi.
Yeah, thank you. So is my screen visible?
Yes, sir.
Okay. Yeah, so yeah, just a second. So yeah, if at any point, if my screen is not visible, please let me know. Because I cannot see the chat. All right. Okay. So shall I start or? Am I audible?
Yeah, yes, audible, but the slide is not visible.
That is not visible?
Yeah, we can see slide, but not in large. Yeah, you can
Okay,
make
wait.
it.
Wait.
Very small. Yeah, yeah. Now, okay, okay.
Okay,
Yeah.
wait. Now do you see it? I am making it full slide. Do you see it now?
No, 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 no.
Okay, wait.
Yeah, yeah. It's fine. Yeah.
Okay, just a second. I will share again. Wait. Okay, do you see my slide?
Yeah, yeah. Now, okay. Yeah,
It's full. You can see the full slide, right?
yeah, yeah, yeah. Yeah.
All right. Okay. All right. So maybe I'll get started. Okay. So thanks a lot for the introduction. So yeah. So I am at computer science department at IIT Kanpur. So today I'm going to present some of the research that we are doing at my lab, the exploration lab in here. So I'm going to first give you sort of an overview of the different research areas that we are working on, and then I'm going to dig deeper into one of the areas I'm going to explain next. So basically, I divide my research into different verticals. So this is like the first vertical, which is the NLP and the NLU vertical. So within this vertical, we work on lots of different research problems. So and broadly, they fall into three categories. So the first one is related to processing legal text. So this is what we call as legal NLP. So the idea is to automatically understand and process legal documents. And this can be useful for different applications like judgment prediction, where you want to predict the outcome of a case. Then legal documents also tend to be fairly long. So the idea here is to divide the legal document into topically coherent units. This is like the semantic segmentation. And then developing large language models for the legal domain and other areas like summarization of legal documents, retrieving prior cases, cross-domain knowledge transfer in legal documents, and so on and so forth. And then the other area that I work in is related to retrieving information from databases. So traditionally, if you want to retrieve information from a database, you would typically write a SQL query. However, for a layman, writing a SQL query is not that straightforward, and it gets even more complicated if you have some sort of like a nesting involved. So the research question that we are asking is that if suppose we could write the query about the information that we see in natural language, can we have a system which can retrieve the information from databases? So the idea here is that the system would take in the natural language query and convert it into some intermediate representation, which will be like an SQL query. And then this can be sort of fired against the database to retrieve the required information. And then the third area in this vertical is trying to teach social norms and ethics to agents. So as many of you would have sort of played with all these large scale language models, right? And you might have noticed that all of them have been trained on sort of Western sort of setting, Western data, and they tend to have the social values and norms of the Western setting. But if you try to query them or try to use them for Indian or maybe like a Nepalese setting or the Eastern setting, they tend to be ignorant about this thing. So what we are trying to do is trying to incorporate that kind of ethical knowledge, in particular the region-specific ethical knowledge into these agents in this. So at any point, if anyone has questions, please feel free to ask. I may not be able to see the chat clearly, so I mean, you can maybe ask over audio itself if possible. All right, so then the other vertical is about trying to model human behavior and the decision-making process. So in this, we are working on lots of different areas. So the first one is has to do with the affective computing. So the idea here, by affective computing, I mean predicting the emotional state of a person. So suppose you have some sort of a video in which different people are talking to each other. You might want to predict the emotional state of each of the person involved in the conversation, right? And as you might have noticed, when you want to predict the emotional state of a person, you need to take into account not just what they are speaking, but also their facial expressions, body pose, their gestures, their speech. I mean, what kind of intonations or prosody they have in their voice. So those all features need to be taken into account. So hence, there is a need for doing something called multimodal learning, which means you try to combine different modalities, like for example, speech, text, video, right? These different modalities to learn some good representations, which can be useful for prediction. And moreover, what you might have noticed is that when people are talking to each other, the context has a very important role to play, and context kind of also governs the emotional state of a person. So for example, if there's a person who is in, let's say, who's talking to another person, and that person is already in some happy mood, then very likely the first person is also going to be happy, right? I mean, so that kind of and also the past context of the conversation is going to decide their mood. So that contextual information needs to be there. So hence what we are trying to do is doing multimodal contextualized emotion prediction. And in particular, we are also working towards incorporating these sort of models for the Indian setting. So most of the data sets that have been developed are for the Western settings. But emotions also tend to be sort of culture specific. So what we are trying to do is trying to have language let's say regional languages or Indian languages into it, and also try to develop data sets which are specific to the, let's say, the Indian subcontinent, right? And then in this in the area of affective computing, we are also working on trying to understand the cause of emotion and how does that affect the decision making process, right? So I mean, usually, I mean, if person is happy, then there is some particular cause. So we want to understand that causal relationship. And obviously, if a person is happy, the kind of decisions that they make is going to be very different from the kind of decisions they will make when they are sort of angry or sad, right? So that sort of decision making is also kind of affected by the emotional state. So in this vertical, another line of research that we are pursuing is focused towards embodied AI. So the idea here is that we want to develop certain agents that can figure out to do things things that you would do very easily in the real world, right? Like, for example, simple daily activities for let's say making coffee, planting a tree, fixing a bike. All these are really straightforward to humans. But if you want to teach, if you want an agent to do this, it's not that easy. I mean, you have to tell them each and every step, and you cannot do it for all the possible tasks, basically, right? So what we want to do is you are developing certain sort of environments where the agent will learn to do these activities by interacting with the environment without any explicit supervision. So these agents are reinforcement learning agents. So the idea here is that the agent is going to interact with the environment and it will be taking certain actions. And if the action is correct, it will get some sort of positive reward, which will tell it that this is the correct action and I should take it next time. And if it does something wrong, then it might get a negative reward, right? So the idea is that it takes sequences of these actions till it reaches the final goal, right? So for example, if the goal is to plant a tree, then it might, let's say, start from scratch, like getting the seeds or digging the ground and so on and so forth, and till it reaches the final goal of planting the tree, right? And it's all sort of driven by the sort of rewards that it gets from the environment. And then the third area that we're working on is on the mental health front. So in particular, what we are trying to do is trying to understand the correlation between speech, language, and speech language neuroimaging data and neuroimaging data for schizophrenia, basically, right? And so in schizophrenia, the patients tend to suffer from some form of a thought disorder, and that also affects their speech and language capability. So we are trying to understand those sort of relationships, and also trying to develop some sort of computational model which could sort of simulate this kind of behavior. And in particular, I mean, for example, you could sort of tune or maybe modify the large language models to exhibit similar behavior, right? And then try to understand what kind of language abnormalities that could happen, basically, right? So that's the third area in this thing. So any questions so far? Does anyone have any questions? I don't know if I'm still audible, right? Am I audible?
Yes, yes.
Okay. All right. So yeah, then the third vertical is AI for social good. So in particular, what we are trying to do is trying to help the deaf community. So so for example, in India, there are around 63 million hard of hearing people, and they tend to communicate with the rest of the population using sign language. However, there is a big communication gap between them and the rest of the population, because the rest of the population doesn't understand sign language. So what we are trying to do is trying to develop technologies and tools to understand and generate sign language. So in particular, this involves things like translating sign language to spoken language, or maybe going the other way around, generating sign language videos from the spoken text, basically, right? So this can be, the idea is to make sort of empower the deaf community so that they can communicate easily with the rest of the population. And we are also trying to work on basically translating the educational content in sign language. For example, let's say educational content corresponding to primary school or maybe higher secondary school level. We are trying to develop, we are working with one organization where we are trying to develop this data set of translation, and then also trying to automate this this process of automatically generating the sign language avatars. All right, so that's those are the sort of the prominent areas of research. If you have any questions, feel free to ask. So in particular, today I'm going to focus on this one particular area that I'm working on. This is called the legal NLP, or trying to understand and process the legal documents. And since I live in India, so I particularly work on the Indian legal documents, right? So so let me sort of start from the grounds up. Why do we actually really care about legal NLP? So as you might be knowing, like India is one of the most populous country in the world, and this sort of also gets reflected in the legal system. So the courts in India are sort of flooded with large number of pending cases, and this has been growing exponentially ever since then, right? And if you look at some of the statistics, so this is the National Judicial Data Grid of India. So this sort of tracks the different cases that are there. So so this was this snapshot I took like few months back. I think the numbers might be much higher now. So there are around like 41 million pending cases in the country right now. So that's a huge number, right? And this number might be, I mean, so there was one estimate by one of the retired Supreme Court judge, and he said, like, if we stop processing cases at this point, and we just wanted to process the existing, I mean, already pending cases, it will take almost like 350 to 400 years to process all the cases. So now you can imagine the scale at which we are talking about, and the sort of the urgency of the situation, right? So so the question that we are trying to ask is, can AI-based technology help and help to make the judicial process sort of efficient? And the idea is that if we can automate even some small components in the in the bigger framework, that can also have a huge impact, because the scale at which we are working is also quite big, basically, right? And obviously, this also can expedite things and help in delivery of justice in a more efficient way. Right. So now the question is, I mean, so legal documents are, I mean, most of the legal things that we talk about is consisting of documents, and these documents sort of are basically written in natural languages, right? So now the question is, why can't we just use the existing tools for processing these legal documents, right? So so one of the challenges with legal documents is that legal documents are like super long, right? I mean, so like, for example, the average length of a Supreme Court document might be around like 4,000 words, basically, right? So these long documents make it difficult to process because information is sort of spread out throughout the document, and it's difficult to link them together. And also, I mean, even if you wanted to use some sort of language model, right? Then language models, so many of these language models also have this limitation of input length, right? I mean, for example, BERT, if you want to use, it has a limitation of 512 tokens or words, basically, right? So I mean, then also it's not that straightforward to use these tools. And then the obviously the second reason is that legal text is quite different from the regular sort of text like used in the newspapers. Legal, I mean, there is like very domain specific lexicon, that is domain specific words that are used. In fact, some of the words which might have, I mean, some of the words which you might find in English or the regular language may have very specialized meaning in the legal parlance, right? So so you need some sort of system which understand this kind of domain specific language, basically, right? So for so here you can see an example, like here, I mean, some specialized terms and words are used in the legal document. So this is an excerpt from a Supreme Court of India document. Right. So then, yeah, and then the other challenge is that these legal documents are highly unstructured. I mean, there's no label associated with different sections of the document, and especially if the document is super long, then it becomes very, very tricky. And many of these legal documents are sort of manually typed in the courts. So that because of that, also it becomes very noisy. It might have spelling mistakes, grammatical mistakes. And also, more practically speaking, when we want to obtain this kind of data, this data might not be in a sort of a digital format. It might be in maybe paper format, and then people might do some sort of OC, maybe scan it and then upload it somewhere on some website, and then it has to be sort of OCR, like you have to apply some kind of optical character recognition to extract the text from that, and obviously that will also sort of introduce more errors into this thing, right? And then yeah, so like as I said, like I mean, the structure is not fixed in legal documents, right? Sometimes, I mean, you have some sort of a legal document here, and then suddenly some point might be mentioned somewhere in between. So it's not that straightforward how to take into account this point in context of the rest of the things that are written there. And then legal domain is further subdivided into sort of many of the non-overlapping subdomains. So for example, you have a separate law for civil cases, separate law for criminal cases. Banking and insurance is a different law, basically, right? So the challenge here is like if you develop a model for one sort of legal or maybe one of the laws, how do you generalize it to other subdomains, basically, right? So that is a very big challenge in here. And then the other requirement or the challenge with developing technological solutions for legal domain is that models have to be explainable. And this is so usually, like when you develop these deep learning models, they are like sort of black boxes, and you don't really actually care much about explainability. And I mean, you're fine. I mean, if model is not explainable, but it is accurate. But here in legal domain, it has to be both. It should be explainable, but also should have decent accuracy. And this is important because if a lawyer is using, let's say, a deep learning model for some legal use case, then they would like to know why this particular decision was predicted by the model. And also for the model to be sort of amenable to legal scrutiny, it needs to be explainable, right? I mean, if something goes wrong, then there needs to be an explanation why this thing went wrong and who's sort of accountable for that, right? So explainability is sort of not a second-class citizen. It has to be like at the forefront, basically. And then, I mean, laws are sort of country and region specific, right? Suppose if I develop a system for, let's say, for the European Union legal system, it may not generalize and work well for the Indian legal system, right? So that is another big challenge. All right, so these are the some of the challenges with processing legal text, and this is the reason that we sort of need some specialized tools for legal domain. And so what is lacking in the current legal domain is that there are no specialized annotated corpora, and very few specialized annotated corpora available. So it is, and since many of the models that we have are sort of supervised, so then you cannot easily train these models because the data is not there. And also annotating legal text is kind of very difficult because this requires experts, legal experts, and this is a sort of an expensive and time-consuming process. And then there is also like a lack of pre-trained language models. I mean, although this has sort of changed a bit now, people have been coming up with legal text specific language models, but still, I mean, it's not at the scale at which you would see in the general NLP domain. And also, even the basic tools to process legal text are sort of lacking there. Like, for example, if you want to do some sort of sentence segmentation for legal text, even that thing is not there, basically, right? I mean, because if you want to segment a sentence in legal text, the regular NLP to sentence segmenter may not work well because the kind of abbreviations that are there in legal text are also kind of very different. Right, so these are some of the typical applications or tasks in the legal domain. So for example, prior case retrieval. So the idea here is that you're given some facts and you would like to retrieve all the past cases which had similar factual situations, right? And then there is summarization. So as I said, legal documents are super long, and if you want to kind of quickly go through this, you might want to have a small sort of summary of the legal documents. And this is where summarization comes into picture. So in legal document, or like maybe like for in the judgment documents, there is some sort of argumentation which happens between the two parties, right, who are kind of contesting the case. And so there is a task of argumentation mining, which would try where one tries to extract the arguments from the case, and this can be useful for different parties to understand what the other party is trying to claim, basically. And then there are tasks, standard tasks like extracting information from legal documents, and then semantic segmentation of the documents, predicting the judgment or legal judgment for a document. So yeah, so this list is not an exhaustive list, and there can be many other possible applications. So this was just to give a sort of a flavor of different things that are there. All right, any questions so far? Anything that anyone wants to ask? All right, so now I'm going to talk about one particular, so now I'm going to talk about some of the applications and some of the things that we have done in this domain. So this is one of our papers. It's called Indian Court Judgment Prediction and Explanation. So the idea here is that we want to predict the judgment or give the final outcome of a case. And I mean, I sort of already motivated why this is important, like as the backlog of cases, pending backlog of cases has been growing exponentially. So if there was a system which could assist or augment a judge by just suggesting the outcome of the case, then it is going to be very useful. So one thing to note here is that we don't want to replace a judge. We are not claiming to make robo judges, basically, right? What we are trying to say is that the system should help a human judge in the predicting the outcome of the case, right? And for this system to be of utility, right, it should be able to explain its decision, basically, right? So suppose let's say predicts the outcome as accepted, or I mean, if some appeal is accepted, then it should be able to explain why that it came to this particular decision, right? So that it is also understandable by the human judge who is using the system, right? And so this is what we propose here, the CJP task, court judgment prediction with explanation task. So the idea here is that you're given some legal document, and then there is an AI system that will predict whether the outcome of this judgment document. So judgment document, obviously the final outcome from these judgment document is not there, and it will predict whether the appeal is accepted or appeal is denied. And so this is the prediction part, and then there is also the explanation part. So for the predicted decision, it also has to basically tell why that particular appeal was accepted or why that particular appeal was sort of denied, basically, right? So that's the explanation part. So this is the entire task. First predict and then sort of explain why this particular decision was arrived. Right. So in particular, what we did was we created a corpus, Indian legal document corpus, and this is annotated with explanations corresponding to different court decisions. And we experimented with lots of different machine learning models, and I'm going to show the results soon. And we performed several case studies to see the difference between what is predicted by the model and by the legal experts. Right, so we observed a significant difference between prediction by the algorithms and by the human legal experts. Right, so there has been there has been a line of research where people have tried to do legal judgment prediction. I'm not going into details of this thing. Different models have been proposed, but what makes our work different is that we are also including the explanation part in that. So most of the previous work didn't have the explanation part. It was just like sort of black box prediction thing. And so we create a new corpus. We call it Indian Legal Document Corpus, or ILDC. And this is a largest corpus of around 34,000 documents. Right. So this is how the corpus was created. So first we extracted Supreme Court of India cases from a website called India Kanun. And this is pre-processed to remove certain meta information. And then gold labels are extracted. And then we created two versions of this corpus. One is the ILDC's single and one is ILDC multi. So what happens sometimes in Supreme Court cases, there might be multiple appeals which are filed in a single case. So that means there would be multiple outcomes. So in this, these kind of documents correspond to ILDC multi. And then for the cases which have a single appeal, this corresponds to ILDC single. So once we have basically these documents, we ask the experts to annotate the final decision. I mean, they also don't see the final outcome, and we ask them to predict the outcome. And also provide the or also highlight the important sections of the document or important sentences in the document which lead to that decision, basically, right? So that's the ILDC expert part of the corpus. So these are some of the statistics. I'm sort of not going into details of these. And we also try to sort of take care of some of the biases that might be introduced. So in particular, we sort of anonymize the names of the judges, appellants, and petitioners. because it has been observed that the judge name is a strong indicator of what the outcome of the case might be, right? So the idea is that system should not take these into account during prediction and should only focus on the facts and the applicable law, right? And also we do not do any sort of time specific splitting of cases in the train, test and development category, because we want that the system that is developed should be sort of time agnostic, basically. And this is sort of the analysis of the so we had 5 experts and we asked them to predict the outcome of the case. So the interesting thing to note here is that even those 5 none of them could reach the 100%. So we compared them with the ground truth, which was the original judgment given by the Supreme Court judge. So we see here that there is a difference between what the experts predict and what was there, right? So this is sort of common. This is sort of expected because India has a common law system where precedent could be sort of overruled, right? So sometimes, I mean, the judge may not go as per the law and might overrule some existing law, basically, right? And yeah, and also the way you interpret these cases also is sort of open to sort of discussion, right? So different experts interpreted the case sort of differently, basically. And then we also sort of do some quantitative analysis using a Rouge score, which sort of measures the as I said, like experts also annotated the explanations in the document, and then we compare these explanations between different and these experts, like 5 experts. So here also we can see that there is not a perfect agreement, although I mean some of these are having high agreement, basically. And then we experimented with lots of different models. As I said, like the average accuracy of the experts is around 93. And we experimented with different, I mean, like the standard Bygru model, and then some transformer-based model. And then in the end, what we saw was that some sort of a hierarchical transformer works the best. And we get a sort of accuracy of around 77%. So there's a huge difference between what the model is predicting and what the experts predicted, right? So this is how the model looks like. I mean, you basically, since the documents is, this is the best performing model, hierarchical, this one, like hierarchical Bygru attention. So the idea here is that since legal documents are super long and there is a sort of a limitation of on the length of the input that a transformer can take. So we divide the documents into chunks, and each chunk goes as input to the transformer. So XLNet is the transformer model here, and we get the representation of each of these chunks, and then a Bygru model is applied on top of that, and then this is used for making prediction, basically, right? And then what we do is this same thing we use for explanation as well. So what we do is we mask one of the chunk and then see if there is a change in prediction. If there is a change in prediction, then we say that this chunk might be important. And within that chunk also we can remove certain sentence and see if there is a sort of change in prediction. So that also sort of tells us if this is important for prediction or not. This is sort of the occlusion method that we are using here. And we saw that these are sort of indicative of the important sentences that are leading to the prediction, right? So these are some of the chunk scores. I'm sort of skipping there. And then we compare the explanation that is given by the model and what is given by the experts. So there is a huge sort of difference. Like, I mean, if you look at Rouge L score, the average Rouge L is around 0.42. And so which is not super high. So, I mean, there is a kind of a difference between how human experts are giving the explanation and how the model is giving the explanation, basically. right? So if you are interested in this work, you can scan this QR code and you can check out this code repository, which has all the code for all the models, and also data set is available. You can download and experiment on your own, basically. Right? All right. So any questions so far? Am I audible? Am I audible or not? Hello?
Hello, sir.
Yeah.
I'm a student here in Nepal, and my question is, using the same model for the legal system in different countries, like in Nepal, how much efforts would that take to tweak this?
So the major effort is going to be creating the data set, essentially, right? On the modeling side, it won't be that difficult, but the difficult part is going to be creating the data set. So for that, you would need to get the documents, the legal documents in digital format, and also annotate them with the explanations, basically, right? I mean, if you're interested in the explanation part as well. So that is, and for that, you will need some legal lawyers, help of the lawyers, basically, right? So that's the sort of the effort that would go in.
Yeah, thank you.
Any other questions?
Do you have any questions? No? Thank you, Ashutosh Modiji.
So
One more question.
Yeah, okay.
And sir, to achieve that level of efficiency, how much data set would we require?
So in our case, we use 35,000, almost 35,000 documents, right? But yeah, I mean, that's a good question, because we don't know, what's the sort of the correlation between the number of documents and the accuracy level, right? So this is something you will have to sort of play. This is something you will have to try out. Like, I mean, you maybe start with, let's say, 20,000 documents and see what level of accuracy you're reaching. If it is not enough, then you might want to increase the number of documents. And also it depends on the length of the documents. If documents are super long, then maybe less number of documents might also help, but it depends, all depends on the, the content of the documents as well.
Modifying the same existing model for a different legal system, would that be any helpful?
Yes, you can do that. Yeah, so that would be a very interesting thing. Suppose you train a model on Indian legal system and then see how well does it work on the Nepalese legal system, right? So that would be an interesting experiment to try. Or maybe if you fine tune the Indian legal model on the Nepalese, how well does that work?
And sir, would it like the models you trained, are those models accessible?
Yes. Yeah. So you see this GitHub repo here, right?
Yes, sir.
So you can download from there.
Okay. Thank you, sir.
All right. So I will just, do I have some time? I want to talk about a little bit more of the work.
Sure, sir.
All right. So yeah, so this is the other work that we did. So here the idea is that, as I said, like legal documents are super long. What we would like to do is we want to divide these documents into topically coherent units. So for example, you might want to get the facts of the cases here, right? And similarly, what are the issues? What is the arguments by the respondent? What is the ruling by the lower court, argument by the petitioner, and so on and so forth, right? So the idea is to structure the document basically, right, into these parts. So this is each of these parts is basically called a rhetorical role, like the facts, issues, argument by respondent, ruling by present court, and so on and so forth. And what we want to do is, given a legal document, we want to assign rhetorical roles to the legal document, right? So these are the rhetorical roles that we are interested in, like facts, arguments, statutes, and so on and so forth. So, obviously this can be useful for lots of different applications, like for summarization, because we can now pick up different parts of the document for summarizing information extraction. Even for prediction, this can be useful, and question answering and so on and so forth, right? So the task here is that given a legal judgment document, you want to automatically predict the rhetorical role label for each of the sentence in the document, right? So for every sentence, you want to assign one of those roles that I showed earlier, right? Like whether it's a fact, it's an argument, and so issue, ruling, so on and so forth, right? So so what we did was we created a corpus of legal documents annotated with these rhetorical roles, and we concentrated on income tax and competition law cases, basically, right? And and then we developed some sort of a model for predicting these rhetorical roles. So the idea behind this model was that if you look at a legal document, there is some sort of a sequence in which these different rhetorical roles occur, right? So for example, usually there would be a preamble, followed by facts, followed by some ruling, arguments, issues, and so on and so forth. This is not fixed, but this is usual trend. Many of the documents tend to follow this sort of trend. So we try to make use of this intuition to sort of to do the prediction. So what we try to do is we want to first do something called label shift prediction. So the idea here is that, let's say you have a legal document and it has like different sentences, S1 to SN. So what you want to do is do some sort of multitask learning. So you want to do two things. One is you want to predict if the rhetorical role label should change from one sentence to another sentence or not. That's the first task. And then that's the auxiliary task. And the main task is to predict the rhetorical role label for every sentence. So here we make use of some sort of a transformer model, like these sentence, we get the embeddings from a transformer model, and then some sort of a bilistium model on top of this, and then a CRF, which predicts whether there should be a shift or not, which is a binary variable. And then there is the main, and this sort of also guides the main component, which tells what is the label of each of the sentence here. Right. So this is the model, and then these are some of the results. So we achieve around like 70% accuracy for both information, income tax and competition law cases, basically. And we tried out lots of different models. And if you're interested in this thing, you can check out this paper. This has all the details and also linked to the code for all these models. I mean, the code is also available there. Right. So this is one. And then another interesting work that we did was so far what I've been doing is working on the English legal documents, but we also did some work on Hindi legal documents, basically, right? So what the idea here is that most of the district courts in northern India use Hindi as the official language, and we want to develop models which can work on Hindi as well, right? So we propose the task of bail prediction. We first create a huge corpus of 900,000 documents, which is Hindi legal document corpus, HLDC. And then we propose the task of bail prediction. The idea here is that given a bail application, you want to predict automatically whether the bail is accepted or denied, basically, right? So this is the process how we created the HLDC corpus. I'm sort of skipping the details here in the interest of time. And then similarly, we created a bail corpus of basically a corpus of bail documents. And so the bail prediction task is that is sort of a binary classification. So we are interested in whether the bail is granted or denied based on given the facts of the case. Goal is to predict whether the bail is granted or denied, basically, right? And then we develop some sort of multitask learning sort of model. I'm kind of skipping many details here, but the general idea here is that given what we want to do is we want to predict the bail prediction, but we also want to predict the important sentences in the legal document, right? So both of them go together in some sort of multitask learning sort of model. And obviously we make use of BERT-based architecture in this thing, right? And if you're interested in this work, I mean, you can scan this QR code. All the code is, code is available on this GitHub repo, and you can download the data set and code and then play with the model, basically. right? And then finally, the one of our latest work, this is on prior case retrieval. So the idea here is that given you want to basically automatically cite the relevant prior legal cases for a query case. So usually what happens if you look at a legal document, there is some sort of, I mean, in the legal document, the previous or past cases are cited based on certain sort of relevance, right? And this relevance corresponds to the facts and the precedence value of the past cases, right? So what we want to do is, and this typically this task has been done sort of manually by the lawyers, right? They will remember which case might be applicable and they would cite it. What we want to do is we want to automate this thing. We want to automatically predict which case should be cited in for a given factual situation, basically, right? And so the idea that we propose here is something called a pipeline called uCreate, unsupervised case retrieval using event abstraction. And so the idea here is that we make use of something called events. So by events, I mean the predicate and the argument structure. So for example, here you can see the sentence, these statements were forced to the police. If you do a dependency parsing of this sentence, then you can get like verbs like forward and the corresponding arguments like statement and police, right? So this tuple statement, forward, and police corresponds to event. So what we try to do is we extract the events from the legal document and for let's say from the query document, and similarly we extract the events from all the candidate documents that we have, and then we try to match what is the overlap in events in the query documents and in the candidate documents. And if there is a high overlap, then it is very likely that that candidate would be cited, right? So this is the sort of the pipeline. You have the candidate documents, you have the query document, you extract the events, and then you see the find out which are the common events, and then you sort of create a rank list of candidates in this, right? And these are some of the results. And we also compare with the transformer-based model. So the surprising thing here is that transformer-based model do not work well in this setting, basically, right? So yeah, so basically, I mean, yes. So I will just sort of conclude there in the interest of time. So I sort of introduce the legal domain here, and then introduce different tasks that I've been doing, basically, right? So just to summarize, so these are the different research areas that we have been working on, and also a little bit of sort of self-promotion here. If anyone is sort of interested, I mean, please drop an email to me.
Excuse me, sir, I have a question.
Yeah.
If it's fine. So I'm from design background. So I'm an architect in Nepal, and I want to know your thoughts on AI, machine learning, and data science in design thinking field like architecture and design.
Okay. Yeah. So actually, I don't work in the architecture and design area, so I don't have much knowledge of these areas per se. But I think at least on the, I mean, so based on the limited knowledge I have, I would suggest that see, AI techniques could be definitely useful in the design area, because I mean, nowadays you might have seen many of these models have come up which can actually sort of given some sort of text prompt, it can generate the image, right? I mean, an example for that was also shown sometime earlier, right? So similarly, I think based on the all the past designs that have been developed, a model could be trained to develop some sort of a new design, come up with a new design, basically, right? And similarly, come up with some sort of new architectural patterns based on the past things that it has sort of learned from, and that could be useful. So it could be sort of augmenting architect in coming up with new sort of designs, basically. Does that answer your question?
Yeah, thank you.
All right. Any other questions? All right. If there are no other questions, so I would conclude there. Okay. Thanks, everyone.
Yeah. Thank you, Ashutosh Modiji, sir. On the behalf of Lumbini Technical University as an organizer, we are very thankful, and we do acknowledge your presentation, and we wish we could have some collaboration on this field. Thank you.
Okay, sure. Okay, thanks a lot. Okay, thanks everyone. Okay, so maybe I'll now leave. Okay.
Thank you, sir. Now I would like to welcome on stage Vice Chancellor, Dean of Lumbini Technical University, Kirti Kusum Joshi, to hand over token of love to Ms. Asmita Mananda Shrestha. Please come up on the stage. Now I would like to welcome Ashok Kumar Pant, sir, to continue his presentation.
Okay, so let's continue from the AIML trend. योभन्दा अगाडि चाहिँ प्रोफेसर इन्डियन प्रोफेसरको टक सुनिसकेपछि मेबी मेरो टक त्यति रमाइलो नहुन सक्छ, बट लेट्स गो क्विक. I will try to wrap up in maybe 10-15 minutes. We'll just go through pretty quickly. Okay. So if you see the real world AI domains in a top 10 list, it might be like, it is like healthcare, finance, agriculture, transportation, retail, marketing, manufacturing, cybersecurity, energy, and education. And beyond this, there can be like telecommunication, government and public sectors like domains. And these domains are using AI in a tremendous way so far. So this is the slide that talks about the next decade technology. Basically, this is prepared in 2018, and it is predicted that the technology trend up to 2028. So यो चाहिँ तपाईको next decade or 2028 भने पनि you can assume कि up to 2030 these technology still have the piece. अब यसमा चाहिँ I will go pretty quickly on this. I will not explain all the components, but if you see in a major way, the top technologies that impact the future are like artificial intelligence, IoT, mobile, social internet, blockchain, big data, automation, robots, immersive media like AR, VR, mobile technologies, 3D, 4D printing, customer experience, energy tech. It is like decentralized energy grids like cybersecurity, nanotechnology, collaborative tech, health tech, human-computer interaction, advanced materials, new touch interfaces, wireless power, clean tech, smart cities, edge computing or fog computing, faster and better internet, and proximity tech. So there are other, technologies also, but these are the major technologies that go beyond the decade and continue growing. र अब मेनली अब क्याटेगोरिकली हेर्ने हो भने चाहिँ देयर आर 4 टेक्नोलोजी द्याट एज्युम that we assume will be trending in the next decade also, like distributed ledger technology, that is blockchain technology, artificial intelligence, and त्यसपछि extended reality, virtual reality र augmented reality को combination, and quantum computing. These technologies will continue on next decade also. र अब हामीले चाहिँ अहिले करेन्ट 2023 को चाहिँ ट्रेन्ड हेर्ने हो र मार्केटको प्रिडिक्सन हेर्ने हो भने चाहिँ सो एआई मेसिन लर्निङ ट्रेन्ड विल बी लाइक दिस. अहिले चाहिँ मार्केट सेयर हेर्ने हो भने चाहिँ इट इज प्रिडिक्टेड 500 बिलियन इन 2023 एन्ड प्रिडिक्टेड 1597 बिलियन बाई 2030. यसको मतलब के हो भन्दाखेरि जुन एआई मेसिन लर्निङको डिमान्ड छ अन मार्केट द्याट विल कन्टिन्यू ग्रोइङ, द्याट विल नट गेट डाउन. सो अर्को ट्रेन्ड हेर्ने हो भने डिप लर्निङ टेक्नोलोजी स्टिल हामीसँग हुनेछ, मेबी 5-10 इयर्स एट लिस्ट. होइन, डिप लर्निङ भनेको चाहिँ मेसिन लर्निङको एडभान्स रूप, एज आई अलरेडी सेड. नेक्स्ट इज फाउन्डेसन मोडल्स, दिस विल बी ट्रेन्डिङ. फाउन्डेसन मोडल भनेको चाहिँ तपाईँहरूको learning in a large volume of data and creating a general model भनेको चाहिँ तपाईको फाउन्डेसन मोडलहरु बनाउने, जस्तो लार्ज ल्याङ्ग्वेज मोडलहरु हुन सक्छ, लार्ज भिडियो मोडलहरु हुन सक्छ, इमेज मोडलहरु हुन सक्छ, एन्ड दोज क्यान बी युज्ड फर डाउनस्ट्रीम टास्क्स. And next is multimodal machine learning. Suppose the task is video transcribing or video to audio or writing text from video, right? That needs two technologies, computer vision and NLP. So we can combine multiple models to decide particular things, or to solve a single problem, we can use multiple models. And this trend will continue beyond 2023. And there is transformers. Transformer ko ta धेरै कुरा आइसक्यो already, हैन? So these transformers are invented back in 2017, sorry. गुगलले चाहिँ हाम्रो ट्रान्सफर्मर चाहिँ रिलिज गर्यो. त्योभन्दा अगाडि चाहिँ हामी आरएनएन मोडल र एलएसटीएम मोडलहरु युज गर्थ्यौ, हैन? अहिले पनि तपाईले कतै कतै हेर्नु देख्नुभयो होला, एलएसटीएम मोडल, आरएनएन मोडल स्टिल देयर. तर मान्छेहरुले अब त्यो एलएसटीएम लङ सर्ट टर्म मेमोरी बेस्ड अथवा रिकरेन्ट न्युरल नेटवर्क बेस्ड मोडलहरु चाहिँ प्रिफर गर्न छोडिसक्यो. एनएलपी टास्कको लागि चाहिँ मोस्टली विल बी प्रिफरिङ ट्रान्सफर्मर मोडल्स. र यसको चाहिँ बेनिफिट के हो ओभर द आरएनएन, फास्ट आरएनएन मोडल भन्दाखेरि जुन एलएसटीएम मोडलहरुमा चाहिँ एउटा ड्रब्याक के थियो भन्दाखेरि दे आर प्रिटी स्लो अन ट्रेनिङ. त्यो सिक्वेन्शियल ट्रेनिङ हुन्थ्यो र त्यो ट्रेन गर्नको लागि चाहिँ हामीसँग डेटा धेरै भए पनि कम्प्युटेसनली इट इज नट एफिसिएन्ट टु ट्रेन इन अ लार्ज भोल्युम अफ डेटा. सो त्यो सेटब्याक थियो. नाउ जब ट्रान्सफर आयो 2017 पछि, नाउ बर्ट भन्ने छ त्यहाँ, अनि T5 भन्ने छ, रोबर्टा भन्ने छ, हैन? यो मोडलहरुले चाहिँ प्यारलिजम चाहिँ इनबिल्ड चाहिँ इन्क्याप्सुलेट गर्यो. त्यो गर्दाखेरि हामीले चाहिँ लार्ज भोल्युम अफ डेटामा चाहिँ ट्रेन गर्न सजिलो भयो. र बेसिक कन्सेप्ट अफ ट्रान्सफर्मर इज समथिङ कल्ड सेल्फ अटेन्सन. एउटा कुनै पर्टिकुलर टोकन अथवा सेन्टेन्स अथवा वर्डमा हामीले चाहिँ केही कुरा ट्रेन गर्नु पर्यो, त्यो वर्डको चाहिँ वेटहरु निकाल्नु पर्यो भने इट विल कम्प्युट द सराउन्डिङ अटेन्सन्स अफ इट एन्ड इन्डिपेन्डेन्टली कम्प्युट फर द्याट वर्ड. सो इट क्यान गो प्यारलल. सो अर्को भनेको एम्बेडेड मेसिन लर्निङ. दिस इज अगेन न्यू ट्रेन्ड इन मेसिन लर्निङ. भनेको इन्ड डिभाइस अथवा आईओटी डिभाइसहरुमा एआई मेसिन लर्निङ इनेबल हुनेछ, सो द्याट डिभाइस इटसेल्फ क्यान हेभ सम लेभल अफ कग्निसन. अर्को चाहिँ नो कोड एन्ड लो कोड इनोभेसन्स. सो फार के हुन्छ भन्दाखेरि अब तपाईले अहिलेसम्म हेर्दाखेरि पनि दिस एआई थिङ, आईटी थिङ इज मोर फर टेक गिक्स अर आईटी इन्जिनियर्स, राइट? तर अब बिस्तारै यो कुरा चेन्ज भएर यु विल सी देयर कि नर्मल युजर अथवा एकदम बेस मान्छेहरुले पनि एआई मेसिन लर्निङ युज गर्न सक्नेछन्. दे डु नट ह्याभ टु कोड or they have to code little bit, but there will be models ready to get the answer, right? So अर्को भनेको few shot, one shot or and or zero shot learning. यो भनेको चाहिँ अलरेडी जुन हाम्रो फाउन्डेसन मोडलहरु छ, प्री ट्रेन्ड मोडलहरु छ, त्यसलाई चाहिँ कुनै नयाँ काम गराउनु पर्यो भने चाहिँ we do not have to train that explicitly on new domain. What we can do is we can just give that a sample examples and then we can request to behave like that. So that thing can be done with these current transformers and foundation models. And there is auto ML. अब एउटा डिफिकल्टी के छ मेसिन लर्निङमा भन्दाखेरि चाहिँ त्यो हाइपर प्यारामिटर ट्युनिङ अथवा मोडल सेलेक्सन, मोडल क्रिएसन पार्ट भनेको एकदमै कम्प्लेक्स प्रोसेस हो। अहिलेसम्म 2014 देखि अहिलेसम्म आउँदाखेरि तपाईले हेर्नुभयो होला त्यहाँ वर्ल्डमा चाहिँ धेरै मिलियन्स मोडलहरु हुँदैनन्, 5-6 वटा मोडलहरु हुन्छ टप परफर्मिङ मोडल एन्ड वी स्टिल रिलाइङ अन देम। त्यो कसरी सम्भव भयो भन्दाखेरि त्यो मोडल सेलेक्सन पार्ट चाहिँ एकदमै क्रुशियल पार्ट, हाइपर प्यारामिटर ट्युनिङ पार्ट चाहिँ एकदम कम्प्युटेसनली कम्प्लेक्स पार्ट हो। वी हैव टु कम्प्युट एभ्री कम्बिनेसन अफ द प्यारामिटर्स एन्ड चुज व्हिच प्यारामिटर्स वर्क्स बेस्ट। So we require some auto ML things for that, like automatic document processing, feature engineering, hyperparameter tuning, even to deployment and preference end. So, and there is generative model. अब मैले ट्रान्सफर्मर र जेनेरेटिभ मोडललाई अलि छुट्याएर किन राखेँ भन्दाखेरि अब नयाँ ट्रेन्ड भनेको चाहिँ क्रिएटिभिटीको ट्रेन्ड हो, नयाँ आइडियाहरूको ट्रेन्ड हो। त्यो हुँदाखेरि त्यहाँ चाहिँ हामीले एडभर्सियरल न्युरल नेटवर्क भन्छ, यो जेनेरेटिभ मोडलहरुमा चाहिँ हाम्रो ट्रेन्ड बढ्ने छ। हामीले नयाँ नयाँ कुरा चाहिँ त्योबाट पत्ता लगाउन सक्नेछौँ। rather existing models, we will have some adversarial encoder decoder models that can get us new ideas and new concepts. And there is transfer learning. अघि एकजना उता सरलाई सोध्नु भएको थियो एकजनाले हैन, जुन चाहिँ इन्डियन चाहिँ हाम्रो डेटा सेटमा ट्रेन गरेपछि is that possible to transfer that learning to our Nepali language or not? Yes, that is possible, right? जब हामीसँग फाउन्डेसन मोडल हुन्छ अथवा कुनै पर्टिकुलर डोमेनमा ट्रेन भएको मोडल हुन्छ, we can take that and learn new things with later small data. यो एक्जाम्पल मानव यस्तो हुन सक्छ, मैले चाहिँ पियानो सिकिसके भनेपछि मेरो टेन्डेन्सी गिटार सिक्ने बढी हुन्छ। भनेको मसँग अलरेडी त्यो पियानोको त्यो म्युजिकको नलेज हुन्छ, ताकि अब म नयाँ चाहिँ मैले चाहिँ अब गिटार सिक्नु पर्यो भने I can learn that pretty fast. So similar approach or similar concept applies to machine learning things also. र reinforcement learning अघि मैले भनिसके, this will again train keep in trending. त्यस्तै हाइपर अटोमेसन, अटोमेसन मात्रै हैन, आरपीए मात्रै हैन, हाइपर अटोमेसन, दिस इज द कम्बिनेसन अफ रोबोट्स एन्ड सफ्टवेयर अटोमेसन। साइबर सेक्युरिटी स्टिल बी देयर। एक्सप्लानेबल एआई, अर्को ट्रेन्डिङ एआई टपिक अथवा टेक्नोलोजी चाहिँ एक्सप्लानेबल एआई हुन सक्छ। यो भनेको चाहिँ हामीले कुनै आउटपुट गेट गर्यौं कुनै मोडलबाट भने वी वान्ट टु नो कि यो किन आयो त, यो के प्यारामिटर के फिचरले गर्दाखेरि यो आउटपुट आयो भन्ने कुरा वी वान्ट नो द्याट। त्यो कुरा चाहिँ कन्टिन्यू हुनेछ ट्रेनिङमा एआई टेक्नोलोजीमा। अर्को छ फेडरेटेड लर्निङ। यो भने यो कन्सेप्ट कस्तो भन्दाखेरि कोलाबोरेटिभ लर्निङ काइन्ड अफ थिङ। जस्तो प्राइभेट अर्गनाइजेसनहरूले त तिनीहरूको डेटा सेयर गर्दैन, तर हामीलाई त एउटा जेनेरिक मोडल बनाउँछ। मानव फर इक्जाम्पल यो हामीले चाहिँ मेडिकल डोमेनमा चाहिँ ट्रेन गरेर एउटा मेडिकल बोर्ड बनाउनु पर्यो, द्याट नो एभ्रिथिङ अबाउट डायग्नोसिस एन्ड एभ्रिथिङ। त्यो अब कसरी सम्भव छ, किनकि मेडिकल हस्पिटलहरूले त आफ्नो प्राइभेसी डिस्क्लोज गर्दैन। इफ यु आस्क देम टु सेयर डेटा, दे विल नट नेभर सेयर देयर डेटा। So there is concept of federated learning, right? Data, they will never send the data to our server. So what happens is they will that model will be trained in their data in their infrastructure, but only trained weights or trained model will be with us and combined in a generic model. So this is a federated learning, new concept and trending thing. And there is ML ops like DevOps, Dev Security Ops, like this is ML ops to maintain, deploy for inferences, the machine learning models, and quantum machine learning. This is new concept. So as you grow, as computing power grows, if we can enable the computation in quantum machines, we can achieve better and more things pretty quickly and in a better way. And there is ethical AI and responsible AI. This is okay. ethical AI and responsible AI is also new term. अब मान्छेहरु बल्ल AI सँग डराउन थालिसके. अब AI सँग डराउने बेला आइसक्यो. त्यही भएर it must follow some social norm, it must be rational, do correct decision. त्यो कुरा चाहिँ हामीले चाहिँ AI मा चाहिँ incorporate गर्नुपर्छ, and this will be trending AI technology or trending AI concepts for next decade, right? So, okay, those are the trends. If you see top companies, I will not go in detail with this, right? You can see these here. These are the most top companies working with AI: Google DeepMind, OpenAI, Microsoft, Facebook, Amazon, IBM, NVIDIA, Tesla, Baidu, Apple. So if you see top influencers in AI, you can follow these guys. So these are the actual technology creators or AI creators like Andrew Ng from Stanford, Fifi Lee, also from Stanford, Yan LeCun from Facebook. So you might know Yan LeCun for LeanIt if you have already some kind of computer vision, deep learning idea, then you know this guy. This is जसले चाहिँ CNN चाहिँ तपाईको लिएर आएमा पब्लिश गरे हैन, यान लुकेन, Joshua Bengio, Canadian computer scientist, Elon Musk, Temis, अनि Godfellow, Kate, Geoffrey Internet, Google, Rick Bourne, Andrees, Adams, Bernard, and Ronald. So these are the top AI influencers you can follow. And if you see some libraries, but this might not be relevant here, you can check some open source libraries, mostly TensorFlow, Deep Learning 4J, MXNet, Caffe, CNTK, Scikit-learn, those kind of things. If you see for data analysis, there are certain lists like Kenny, Weka, kind of thing. Okay. So if you want go for some awesome resources, you can search for awesome machine learning, awesome AI, awesome deep learning, awesome NLP, and you will get lots of ideas there, accumulated ideas, and you can follow those resources to know what is going on the particular field, what are the recent advancement, what people are doing, what papers are publishing out there. You can check that. Okay, to the last. This is my last slide. AI, democracy and future of civilization. अघि मैले भने ethical AI, responsible AI. So मैले पनि यो सुरु गर्न थालिसके कि अब चाहिँ AI should be responsible. It should be ethical. अब हामीले चाहिँ ब्याक 2010 बाट सुरु गर्दाखेरि 2012 बाट सुरु गर्दाखेरि इभन मलाई 2019 सम्म मलाई त्यस्तो लाग्दैन कि AI can disrupt or AI can take over the civilization. तर मैले जब यो भन्दा 1-2 वर्ष अगाडि चाहिँ सुपर AI भन्नेमा एउटा टक दिएको थिएँ, त्यो बेला मैले सर्च गर्दाखेरि आई थिंक कि दिस माइट बी द सिनेरियो कि AI टेक ओभर द सिभिलाइजेसन एन्ड डेमोक्रेसी. एउटा म सानो डेमोक्रेसीको टेक ओभरको इक्जाम्पल भन्छु. अब प्रोपोगेन्डाहरू जसरी पोलिटिकल प्रोपोगेन्डाहरू, इलेक्सन प्रोपोगेन्डाहरू मार्केटमा सोशल मिडियामा फ्लो गरिन्छ, त्यो कुराले गर्दाखेरि जुन डेमोक्रेसीको नर्म हो त्यो फेल हुन सक्छ. एउटा इक्जाम्पल के हुन सक्छ भन्दाखेरि हामीले यस्तो AI बोटहरु बनायौं, त्यसले चाहिँ कुनै एउटा युजरले कन्भिन्स गराउनु पर्यो केही कुरा, केही प्रोडक्ट बाइङको लागि होस् अथवा कसैलाई चाहिँ मैले भोट गर्नको लागि होस्, कसैको फेभरमा बोल्नको लागि होस्, मैले 10 वटा बोटलाई चाहिँ कन्भिन्स गराउनको लागि लाए. म चाहिँ डेली सोशल मिडियामा अथवा मेरो पहुँचमा तिनीहरूले चाहिँ मलाई त्यो नलेज चाहिँ ट्रान्सफर गरिराछन् भनेपछि यो हुन सक्छ कि म त्यो बोटमा ओरिएन्ट हुन सक्छु, उसको बिहेभियर बानीलाई चाहिँ म ट्रु भन्न सक्छु, एन्ड दैट विल अब त्यसले चाहिँ डेमोक्रेसीलाई चाहिँ ह्याम्पर हुन सक्छ. अर्को चाहिँ जस्तो अब हामीले चाहिँ सुपर ह्युमनको कुरा गर्यौं, जीपीटीहरु आइसक्यो, यस्तो केस हुन सक्छ कि अब यो त जेनरेटिभ कुरा हो हैन, इट क्यान जेनरेट न्यू आइडिया. टाइम मे अराइज कि यसले आफ्नै न्यू स्पिरिचुअल स्क्रिप्ट लेख्न सक्छ, मेबी लाइक बाइबल, भगवत गीता. इट क्यान राइट इट्स ओन एन्ड पिपल क्यान फलो द्याट. र त्यसको आफ्नै छुट्टै दुनिया हुन सक्छ. AI क्यान क्रिएट इट्स ओन वर्ल्ड र त्यसले चाहिँ सिभिलाइजेसनमा चाहिँ हुन सक्छ, खतरा हुन सक्छ. So we have to be responsible with AI. We have to keep it safe, make it safe, and follow social norms. Thank you. Okay, you can ask any questions. ठ्याक्कै अटो जीपीटी भने त जीपीटी कै पार्ट भइहाल्यो हैन। अब मोडलहरु कस्तो हुन्छ भन्दाखेरि ओपन सोर्स मोडलहरु छ, जस्तो जीपीटी 4 जीपीटी 3 इज क्लोज्ड सोर्स मोडल, राइट? वी डोन्ट नो कि कसरी त्यो ट्रेन गर्यो, कति डेटामा ट्रेन गर्यो, व्हाट इज द मोडल साइज. People are talking about 3 billion 6 billion parameters are out there हैन। अहिले जुन हामीसँग एभाइलेबल जुन जीपीटी मोडलहरु छ, ट्रान्सफर्मर मोडलहरु छ, त्यो भनेको 13 बिलियन 30 बिलियन 60 बिलियन 175 बिलियन सम्मको मोडलहरु छ के ओपन सोर्स। त्यो अटो एमएल अटो जीपीटी इज ए ओपन सोर्स थिङ एन्ड सिमिलर टु ट्रान्सफर्मर दिस जीपीटी थिङ। अब अल्गोरिथमिक बायस आई एम नट श्योर अबाउट दैट. What is algorithmic bias? Assigning bias algorithmically? अब त्यो चाहिँ अब सबै मेसिन लर्निङ मोडलमा हुन्छ हैन। जुन मैले अघि सुरुमा मेसिन लर्निङको म्याथमेटिक्स भन्दाखेरि त्यो हाइपर प्यारामिटर दिएको थिए, देयर इज वन बायस प्यारामिटर इन्क्लुडेड इन दैट टु। त्यो भनेको चाहिँ हामीले कुनै कुरालाई फेभर गर्नु पर्यो भने चाहिँ वी क्यान सेट दैट भ्यालु। दैट क्यान बी आइदर सेट विथ programmatically itself or manually you can give some bias to that. Any other questions? Okay. Okay, thank you. Next, registers.
Thank you so much, sir. Now we are at the end of our symposium. So for the summary and closing, let's welcome Mr. Rez Bhandari, Registrar of Lumbini Technical University, again on stage to deliver a summary of today's event and offer his concluding thoughts.
विश्वविद्यालय किन बनाइयो भन्दाखेरि प्राविधिक विश्वविद्यालय भनेर घोषित गरियो, जसमा सूचना प्रविधि, इन्जिनियरिङ, कृषि, वन, पर्यटनमा हाम्रा क्लासहरू सञ्चालन हुनेछ भनेर विशेष गरी आईटी इनेबल्ड एजुकेसन हुनुपर्छ भन्ने हिसाबले प्रदेश सरकारले लक्ष्य लियो, त्यही अनुसार बनायो। त्यस्तै सूचना प्रविधि पहुँच कसरी बढाउने, प्रादेशिक सूचना पोर्टलहरू कसरी बनाउने भन्ने कुरामा कानुन बनाए सबै कुरा भनेको सबैभन्दा हामीले आवश्यक पर्ने कुरा भनेको लेगल फ्रेमवर्कहरू हो। यो लेगल फ्रेमवर्क नबनाइकन हामी अगाडि बढ्न सक्दैनौँ। त्यसैले आवश्यक संरचनाहरू, आवश्यक नीतिगत कुराहरू बनाउनु पर्छ भन्ने कुराहरू जोडिएको छ। त्यस्तै 77-78 मा के गर्यो सरकारले, 78-79 मा के गर्यो र 79-80 मा के भयो भन्ने कुराहरू गरिएको छ। जस्तो मन्त्री परिषद बैठक व्यवस्थापन अभिलेखीकरण डिजिटाइजेसनमा 40 लाख खर्च गर्ने, डिजिटल प्रदेश प्रबन्धन कार्यक्रम 10 लाख खर्च गर्ने, प्रगति विवरण प्रविष्ट सम्बन्धी सफ्टवेयर निर्माण 10 लाख। यसरी सूचना प्रविधिको प्रयोगबाट सरकारी सेवा प्रवाह कसरी राम्रो गर्न सकिन्छ, हाउ क्यान वी better deliver a government e-governance service in province level and local level. So government has given some priority on ICT than other province. Then similarly what we do in the context of 77, 78 and 80. मैले धेरै म पढ्न गएन र धेरै कुराहरू हामीले यहाँनिर एउटा प्रदेश सरकार हेलो मुख्यमन्त्री भन्ने कार्यक्रम चलाएको थियो, जसको लागि पैसाहरू खर्च गरेको छ, जसमा चाहिँ ग्रिभेन्स ह्यान्डलिङ सिस्टमहरू प्रयोग गरिएको थियो र त्यो कुराहरू भाइ बहिनीहरूलाई काम लाग्न सक्छ। त्यस्ता सिस्टमहरू एआई बेस्ड अथवा कसरी अहिलेको ग्रिभेन्स ह्यान्डलिङ बेटर हुन सक्छ भन्ने कुरा तपाईहरु सोच्न सक्नुहुन्छ। अब यहाँ पनि हामीले के गरेका छौँ भन्ने कुरा विभिन्न सफ्टवेयरहरूको लोकल ल्याङ्ग्वेजबाट एग्रो बेस्ड लोकल ल्याङ्ग्वेज कसरी म्यानेज गर्ने, ब्लकचेन बेस्ड स्मार्ट कन्ट्याक्ट सिस्टम र एग्रो कम्पनीहरूलाई कसरी एकै ठाउँमा ल्याउने भन्ने कुराहरूको सोच समेत राखिएको छ। त्यस्तै एआई बेस्ड माइक्रो क्लाइमेट एनालाइसिस सिस्टम पनि इम्प्लिमेन्टेसनमा छ। पार्सली हामीले यसको डेटाहरू लिएका छौँ, तर कम्प्लिट यसलाई हामीले फुल्ली फङ्सनमा ल्याउन सकेको छैन प्रदेश सरकारले। त्यस्तै सर्भेलेन्स सिस्टमहरू, सेक्युरिटी सिस्टमहरू कसरी जेनेरेट गर्ने भन्ने छ। त्यस्तै नेपालको यो जुन डिजिटल फ्रेमवर्कलाई कसरी प्रदेश र स्थानीय सम्ममा लाने र अस्पताल र इआरपी सिस्टम कसरी बनाउने र उद्योग सफ्टवेयर कसरी बनाउने कस्तो हुनुपर्छ भन्ने कुरा र साथै अब यो लुम्बिनी प्रदेश चाहिँ यो पहाडी भूभाग भएको हुँदाखेरि पहिरो पनि जाने र तराई भूभाग बाढी डुबान पनि हुने भन्नाले यो डिजास्टर म्यानेजमेन्ट सिस्टमहरू अथवा फ्लोड म्यानेजमेन्ट सिस्टमहरू के हुन सक्छ, त्यस्तो कुराहरू अर्ली वार्निङ सिस्टमहरू के हुन सक्छ भनेर तपाईहरु भाइ बहिनीहरूले पछि प्रोजेक्टको लागि काम लाग्ने यस्तो किसिमको कुराहरू तपाईहरु बनाउन सक्नुहुन्छ। त्यो कुरा पनि छ। त्यस्तै अब हामीले सूचना प्रविधि प्रतिष्ठान अन्तर्गत प्रत्येक मन्त्रालयको वेबसाइटहरू युनिफर्मेटमा छ र त्यस्तै प्रत्येक पालिकाको वेबसाइटहरू एउटा युनिफर्म कमन फ्रेमवर्कमा छ, जसले गर्दाखेरि कम्प्याटेबल र कन्सिस्टेन्सी कुराहरू मेन्टेन गर्न सजिलो हुन्छ र त्यो तपाईहरुले जीए आर्किटेक्चर अनुसार गराउनु पर्ने हुन्छ, त्यही अनुसार बनाइएको छ। त्यस्तै विश्वविद्यालयको उद्देश्यहरू छ। विश्वविद्यालय केका लागि, प्रदेशको लागि आवश्यक पर्ने इन्जिनियरिङ, कृषि, वन, पर्यटन तथा सूचना प्रविधि जस्ता प्राविधिक विषयमा उच्च अध्ययनको लागि बेसिकली हामी मास्टर्स र स्नातक तह सञ्चालन गर्नेछौँ र यो कुराहरू यति कुरा मैले राखेँ। र त्यसमा विशेष गरी विश्वविद्यालयले केमा ध्यान दिएको छ भने ज्ञान र प्रविधिलाई बौद्धिक सम्पत्तिको सम्बन्धी अधिकार सम्बन्धी अथवा प्याटेन्ट राइट सम्बन्धी काम गर्ने भनेर जुन नलेज बेस्ड इन्डस्ट्री छ त्यसलाई चाहिँ बढी फोकस गरेको छ, अथवा सफ्ट स्किललाई फोकस गरेर विश्वविद्यालय चल्नुपर्छ भन्ने भिजन रहेको छ। त्यही अनुसार अगाडि बढ्ने सोच रहेको छ। र हामीले कार्यक्रमहरू बिटेक इन आइटी, बिटेक इन सिएस एन्ड एआई, बिटेक इन आइटी इन्जिनियरिङ, त्यस्तै त्यहीसँग सम्बन्धित मास्टर्स प्रोग्रामहरू र मेजरिङ नेटवर्क, साइबर सेक्युरिटी, डेटा एनालाइसिस आजका जति पनि कुराहरू गरिए त्यस्ता किसिमको कन्टेम्पोरेरी सब्जेक्टहरू सञ्चालन हुनुपर्छ भन्ने उद्देश्य लिएको छ। प्रदेशमा कतिवटा दरबन्दी छ, कति पूर्ति भएको छ, कति खाली छ, मतलब तपाईँहरूको स्कोप छ यहाँनिर। अझै पनि के छ, हाम्रो प्रदेश सरकारमा 108वटा दरबन्दी मध्ये 46वटा मात्रै आइटी अफिसर भएको छ, अरू बाँकी छ। तपाईहरु ग्रेजुएट हुने बित्तिकै अथवा ब्याचलर कम्प्लिट गर्ने बित्तिकै एज आइटी अफिसर त्यहाँ छिर्न सक्नुहुन्छ। रादर देन जब सिकर यु शुड बी अ जब क्रिएटर, बट एटलिस्ट देयर आर सम स्कोप्स वेयर यु क्यान जोइन गभर्नमेन्ट जब्स सो अन। र सम्पूर्ण हामी लुम्बिनी प्रदेशमा 109वटा पालिका छ। 109वटा पालिकामा 109वटै आइटी अफिसर राख्नुपर्ने हो, तर अझै पनि 13-14वटा बाँकी नै छ। मतलब स्कोप आइटी को नेपालको कन्टेक्स्टमा हाम्रै प्रदेशमा पनि आवश्यक छ भन्ने कुरा यसले जनाउँछ। त्यस्तै हामी ह्युमन क्यापिटलमा कति पर्सेन्ट इन्गेज छौँ भन्दाखेरि आइटीबाट 1.2% इन्गेज छौँ र लुम्बिनी प्रदेशमा 8% र बागमतीमा चाहिँ 66% र कर्णालीमा 2% चाहिँ व्यक्तिहरू बढी इन्गेज हुनुहुन्छ भन्ने कुरा देखाइएको छ। र प्रायः जसो ट्रेनिङहरू दिने कुरामा चाहिँ अहिलेको चाहिँ डेटा भिजुअलाइजेसनका कुराहरू, जीआइएस का कुराहरू, डेटा कलेक्सनका कुराहरू, गुगल स्टोर यस्ता कुराहरू चाहिँ प्रायः जसो ट्रेनिङहरू सरकारले ह्युमन क्यापेसिटी डेभलपमेन्टमा खर्च गरिरहेको छ अथवा त्यसका लागि क्षमता विकासमा काम गरिरहेको छ भन्ने हो। त्यस्तै डेटा इन्डस्ट्रीहरू कति छन् त आइसिटी इन्डस्ट्रीहरू भन्दाखेरि हाम्रो टोटल 0.3% छ भने प्रोभिन्स वाइज लुम्बिनी प्रोभिन्समा 12% छ आइटी इन्डस्ट्री, बागमतीमा 48% छ, कर्णालीमा 3% छ, अरूको राखिएको छैन। त्यस्तै यो सर्भिस प्रोभाइडर को छन् भन्ने कुराहरू मैले भनेन। यसमा तपाईहरुले के सोच्नु पर्यो, आईएसपी टेलिकम सर्भिस प्रोभाइडर, इन्टरनेट सर्भिस प्रोभाइडर, पेमेन्ट सर्भिस प्रोभाइडर एन्ड अदर रुरल इन्टरनेट सर्भिस प्रोभाइडर, जीएसएम सेलुलर प्रोभाइडर, यिनीहरू कति छन् र त्यसको तपाई एज अ एन्टरप्रेन्योर बन्नुहुन्छ भने त्यही अनुसार हेर्नु पर्यो, एज अ जब सिकर बन्ने भने त्यही अनुसार खोज्नु पर्यो भन्ने कुराहरू आउँछ। नेपालमा पेनिट्रेसन कति छ, जीएसएम को टोटल ओभरअल टेलिकम्युनिकेसन पेनिट्रेसन कति, आईटी को इन्टरनेट पेनिट्रेसन कति भन्ने कुराहरू यहाँ देखाएको छ। हुन त हाम्रो पपुलेसन भन्दा बढी मोबाइल पेनिट्रेसन छ, त्यसै लगभग पपुलेसन जति इन्टरनेट पेनिट्रेसन छ र कुन जिल्लामा यो ग्रामीण दूरसञ्चार विकास कोष भन्ने तपाईहरुले यो आईटीमा पैसा छैन भन्नुहुन्छ, तर यो ग्रामीण दूरसञ्चार विकास कोषमा लगभग 24 अरब पैसा छ जसले रिसर्चमा फन्डिङ गर्छ। तपाईहरुले त्यहाँ गएर आक्स सोध्न सक्नुहुन्छ। त्यस्तै यूजीसीले फन्डिङ गर्छ, डिफ्रेन्ट सोर्सहरु छ। तपाईहरु रिसर्चमा समस्या पर्यो भने त्यहाँ गएर रिसर्च गर्ने र फन्डहरु ल्याउन सकिन्छ। र यो ग्रामीण दूरसञ्चार विकास कोषबाट लुम्बिनी प्रदेशमा रोल्पा रुकुममा वर्ल्ड लिङ्क कम्युनिकेसनले काम गरेको छ। त्यसलाई पालिकाबाट सबै वडाहरू जोड्ने कामहरू अप्टिकल फाइबरबाट, जस्तो कुनै पालिकामा 8 वटा वडा छ भने 8 वटा वडासम्म कसरी पुर्याउने त, त्यसो किसिमले काम गरेको छ। मैले धेरै यसमा लामो भनेन किनभने तपाईहरु धेरै थाकिसक्नु भएको छ। अब त्यहाँ हाम्रो लुम्बिनी प्रदेशमा भएका वेबसाइटहरुमा अघि नै भने कन्सिस्टेन्सी एउटा फ्रेमवर्क छ, सबै मन्त्रालयको, सबै निर्देशनालयको र सबै पालिकाको वेबसाइटहरु एउटै फ्रेमवर्कमा चलेको छ। त्यस्तै कर्मचारी सूचना प्रणाली छ, अनलाइन सवारी चालक अनुमति दर्ता, एकीकृत सूचना पोर्टल भनेर ओभरअल लुम्बिनी प्रदेशको तपाईले गाउँपालिकामा कति वडा कार्यालयको वडाधीशको त्यसको फोन नम्बर के हो, इमेल के हो, त्यो सबै सर्च गर्न पाउने अप्सन सहित त्यहाँको एउटा इन्टिग्रेटेड पोर्टल सञ्चालन छ। त्यही अनुसारको अरु प्रदेशमा पनि हुनुपर्छ जस्तो मलाई लाग्छ, जसले गर्दाखेरि तपाईले डेटा लिन सक्नु भने समयमा डिसिजन दिन सक्नुहुन्छ। त्यसैले एउटा राम्रो काम भनेको एकीकृत सूचना पोर्टल छ, तपाईले त्यहाँ भिजिट गर्न सक्नुहुन्छ। मुख्यमन्त्री कार्यालयको वेबसाइटमा गएर त्यहाँ लिंक छ। त्यस्तै प्रदेश लोकसेवाको अनलाइन एप्लिकेसन, सहकारीको कोपोमेस, हेल्थमा EHR र इम्प्लिमेन्ट पोर्टल भनेर यो अनगोइङ प्रोजेक्ट छ र यो सबैले जीआई का स्ट्यान्डर्डहरु फलो गरेर काम बनाइरहेका छन्। त्यस्तै हामीले प्रत्येक पालिकामा आईपीएफ इनोभेटिभ फन्ड पार्टनर अन्तर्गत यो सन्धिखर्क नगरपालिकामा एकीकृत नगर प्रणालीको सफ्टवेयर डेभलप भएको छ। यशोधरा नगरपालिकामा डिजिटल सेवा केन्द्र कमन सर्भिसको डेभलप भएको छ। त्यस्तै तिलो तमाम चाहिँ सूचना मार्ग भनेर प्रत्येक पालिकाबाट, पालिकाको अफिसबाट प्रत्येक वडा कार्यालयसम्म जोडेर त्यहाँ चाहिँ प्रत्येक मोबाइल एप्समा के कुराहरू मोबाइल एप्स बनाइसकेपछि विज्ञापनहरू, लोकल विज्ञापनहरू, अन्य विज्ञापनहरू राखेर रेभेन्यू जेनेरेट गर्ने एउटा प्लेटफर्म पनि बनाएको छ। त्यसलाई तपाईहरुले एउटा रिसर्चको प्लेटफर्म हेर्न सक्नुहुन्छ। त्यस्तै यशोधरामा डिजिटल एजुकेसन ट्रान्सफर्मेसनको लागि लर्निङ म्यानेजमेन्ट सिस्टम बनाएको छ र त्यहाँनिर गाउँपालिकाले केही भन्नु छ भनेर सुनिल स्मृति रोल्पाले चाहिँ एउटा एप्स बनाएको छ, त्यसलाई चेक गर्न सक्नुहुन्छ। लुम्बिनी प्रदेशले अघि मैले भने जस्तै लुम्बिनी प्रदेश एकीकृत सूचना प्रणाली कतिवटा मन्त्रालय छन्, कतिवटा निर्देशनालय छन्, कतिवटा संस्था छन्, त्यसको हेड को हो, त्यसको कन्ट्याक्ट नम्बर कति हो, जेन्डर वाइज कति इम्प्लोइ छन्, क्वालिफिकेसन वाइज धेरै किसिमले डेटाहरू सर्च गर्न सक्छ अथवा तपाईले केही डेटा सेटका आधारहरू पाउन सक्नुहुन्छ। त्यसको लागि plgportal.lumbini.gov.np यहाँ गएर तपाईले त्यो एकीकृत पोर्टल हेर्न सक्नुहुन्छ। त्यसको भएका फिचरहरू सबै यहाँनिर पाउन सक्नुहुन्छ। त्यसै लुम्बिनी प्रदेश चाहिँ यो लिजा भन्ने छ, यो लिजा भनेको लोकल गभर्नेन्सको एउटा सेल्फ एसेसमेन्ट फ्रेमवर्क छ। त्यो फ्रेमवर्कले 7 वटा प्रदेशमा यो 10 वटा प्यारामिटरमा काम गर्छ। शासकीय प्रबन्ध, संगठन तथा प्रशासन, वार्षिक बजेट र योजना व्यवस्थापन, भौतिक पूर्वाधार, सामाजिक समावेशीकरण, सहकार्य समन्वय, वातावरण संरक्षण भनेर 10 वटा प्यारामिटरमा कति कुन लेभलमा कुन प्रदेशले काम गरेको छ भन्ने कुरा प्रत्येक वर्ष एसेसमेन्ट हुन्छ। त्यो अनुसार सुरुको वर्ष 76-77 मा चाहिँ लुम्बिनी तल थियो, 51% मात्रै थियो भने 77-78 मा चाहिँ 63% भयो र अहिले टप मोस्टमा लिजाको फ्रेमवर्क अनुसार लुम्बिनी प्रदेशले आफूले गर्नुपर्ने ट्रान्सपेरेन्सीहरू अकाउन्टेबिलिटीहरू मेन्टेन गरेको छ र त्यसको लागि प्राय जसो आईटी नै प्रयोग गरिएको छ र गभर्नमेन्ट इन्डेक्समा अघि भनिहाले नेपालको इन्डेक्स 2003 देखि 2023 सम्म कति छ अहिले हामी 121औं स्थानमा छौं 193 मध्ये यो तपाईहरुले प्यारामिटर हेर्न सक्नुहुन्छ यो बढ्दै छ घट्दै छ फेरि यहाँदेखि हामी चाहिँ पिकअप लिएका छौं र च्यालेन्जहरु प्राय जसो भनेको लेगल फ्रेमवर्कहरु हो हामीसँग सफिसिएन्ट डकुमेन्ट कानुनी प्रारूप नहुँदाखेरि हामी दुःख पाउँछौं र पहिले बनाइसकेपछि जस्तो बिटकोइनको कुरा आयो त्यसको कानुनी प्रारूप छैन एउटा नेपाल प्रहरीले हुँदैन भन्नेपछि अब भएन त्यही अनुसार राष्ट्र बैंकले गभर्न गरिरहेछ तर लेगल साच्चै फ्रेमवर्क के हो त सरकारको भन्दा सरकारको फ्रेमवर्क त छैन फेरि है त्यस्तै क्वालिफाइड ह्युमन रिसोर्स पाउन चाहिँ गाह्रै छ र तपाईहरु अहिले धेरै जसो विद्यार्थी मैले देखिरा भाइ बहिनी देखेको हुँदाखेरि तपाईहरुले आईटी मा एनफ स्कोप छ त्यसलाई तपाईहरुले आफ्नो स्किललाई शार्पेन गर्नु पर्यो अथवा अलिकति राम्रो बनाउनु पर्यो रिलायबल र रोबस्ट आईसीटी इन्फ्रास्ट्रक्चर नेसेसिटी छ लिमिटेड इन्भेस्टमेन्ट आईसीटी मा प्राय जसो सूचना प्रविधिमा लिमिटेड इन्भेस्टमेन्ट नै छ यसलाई अब सरकारले बढी इन्भेस्टमेन्टको प्रायोरिटी दिनुपर्छ अर्को भनेको विलिङनेस र इन्टलाइजेसन यो पोर्टल मैले अघि नै भने तपाईहरुले हेर्नु होला त्यसमा दिएका सर्भिसहरु इलेक्टेड रिप्रेजेन्टेटिभ कति हुन् निर्वाचित व्यक्तिहरु स्टाफ कति छन् वेबसाइटको डाइरेक्टरी के छ के डकुमेन्टहरुको जस्तो कतिवटा तपाईहरुले पालिकामा कतिवटा सिफारिस पत्र चाहिन्छ होला कतिवटा सिफारिस पत्र जस्तो तपाईँ जन्म मृत्यु बसाइसराई भनेर 5 भाइटल रेजिस्ट्रेसन भन्छ 5 वटा त्यो बाहेक अरु तपाईले अब जेएनदार छात्रवृत्तिको लागि छात्रवृत्ति स्कलरशिप पाउनु पर्यो अथवा अन्य अरु कुनै पासपोर्ट लिनु पर्यो फेरि सिफारिस चाहिन्छ हो नेशनल आईडी लिनु पर्यो सिफारिस चाहिन्छ देयर मोर देन 62 टाइप्स अफ रिकमेन्डेसन लेटर रिक्वायर्ड अब त्यसको मात्रै अघि जुन उहाँले एउटा देखाउनु भएको थियो के इन्डियन प्रोफेसरले त्यसलाई हामीले कसरी मेसिन लर्निङ अथवा डेटा साइन्स युज मेसिन लर्निङ अथवा एआई युज गरेर त्यो रिकमेन्डेसन लेटर चाहिँ छिटोबाट सर्भिस प्रेडिक्सन गर्न बनाउन सक्छ एउटा प्रोजेक्ट वर्कहरु त्यहाँ पनि हुन सक्छ रिकमेन्डेसनलाई मात्रै ठ्याक्कै यो अनुसार यसरी छिटो बनाऊ भनेर प्रेडिक्सन गर्दैन हामीले त्यो ठूलो लेगल वर्क त बनाउन नसकौँला तपाईहरुको ब्याचलरमा त्यो प्रोजेक्टसम्म गर्न सक्नुहुन्छ सर्भिसेसहरु के दिएको छ पालिकाले इन्फर्मेसन के छ रिसोर्स म्यापहरु के छन् यसरी यो तपाई त्यहाँ पाउन सक्नुहुन्छ plgportal.lumbini.gov.np बाट यति कुरा छ मैले यति कुरा राखे छोटो समयमा अथवा धेरै बसेको मैले धेरै समय पनि लिन चाहेन अब म